Oh, man. Oh, I'm not muted. Hi. This is me coughing. I guess allergies are really bad today or something. Something just is terrible today. Can't wake up. Wake me up inside. Let me turn on lights. Let's see, lights. God, I need a haircut. The humidity is really messing with my hair today. Toggle, toggle, toggle. Don't have automation yet. Still waiting to figure out what what needs to be done in order to run Node-RED and my MQTT broker. I don't know why the MQTT broker is so important. It seems a little crazy. I guess it just makes it easier for you to assign like functionality, like move packets around and stuff. It'll just move those HTTPS packets without you having to make them. I suppose could I do without the MQTT broker and just send requests directly from Node-RED? I'm not sure. Not sure about that. Well, anyway, we need to start up all of my programs. So I need to start. We already have GIMP open, but this is the old version, so I'm not going to save this. I'm just going to close the whole program. Discard the changes. Let's open up GIMP again. Oh, you know what I need to do? I need to get into the file server. Does this work? Oh, it does. Okay, so I can get into the file server via the Z drive. So let's start up Fusion and get that updated. Because we're going to do, what we're doing is we're putting all of the elements of this synthesizer into Fusion. So not only do I have a working schematic of what's actually there, but I also have a design that I can go off of. I can actually turn that into my own circuit board. Sign in. All right, let's go to Facecam for a little bit here so I can sign into Fusion. That's so weird. I guess I haven't used Fusion on this computer in a little bit. 6-digit code. You guys aren't allowed to see any of this stuff. This is all forbidden knowledge. Update your authenticator app setup. Remind me later. We'll do that when I'm not on the air. God, I gotta open up the identity manager. I gotta do all this crap. There we go. Now we're logging in. Bother, Bobbies. Bother and Bovies. Oi, it's the Bovies. Scarper. My accent breaks down after a word or two. It's the Bovies. Oi. All right, we can probably put this mostly back together until we're actually working with the hardware again. I'm going to put Dave's synth back together in the state that it's in, which there are chips missing and stuff. Oh yeah, I can't put it back together because the plugs are on the opposite side. That's funny. I can't actually put it back together at all. All the king's horses. The strategy here is that once I get the schematic going, I'll have a better impression of how the m303 functions, and that will lead into basically going from start to finish with this thing and making sure that each step of the way functions properly. We need to do this piecemeal. I need to go section by section because there's like little things are wrong with it, and I don't know what. My hair is starting to drive me crazy. It's like super hot and humid here, and so what that does is it frizzes up my hair. Let's update Fusion. SolidWorks is not that solid. How's it going, Piano Cat? How you been? I can't seem to wake up today. I think I got enough sleep because I don't feel that lack of sleep holding me back. It's just like my face is puffy, and I think it's just like humidity and allergies are getting to me finally. It's a good day to stay locked inside, although it is less humid outside. It's a lot less humid. Maybe I just need to let in fresh air. But I feel like I could splash cold water on my face right now. I could use that. Let's do a little, first of all, just a little test. That did not show up on social stream. What's going on? Oh, I don't have it open. That's why. Well, that should still show up on... Okay, there's that one. NanoCat's messages went through from Twitch. Why isn't YouTube? Let's try it again. Ah, what the hell? That was the current one. I did open up my YouTube channel. Let's try doing it again. Why is it less humid outside? It's just the weather. Wait, what's going on there? Why did this suddenly stop responding? Weird. That one showed up in social stream finally. And then the Twitch chat one seemed to do a test on that one. Didn't show up there. What the hell's going on? I'm gonna reload the Twitch chat. There's the Twitch chat back. Remember, it's less humid inside. Yeah, we have the AC making it less humid inside. It's still humid outside, and I guess that frizzed up my hair in the morning because I took the dog for a walk with wet hair. So when it dried, I don't know, now it's all over the place and frizzy and I can't get it out of the way. Fusion is updating right now, so it's gonna be a little choppy in here. And then I need to take my chat over here. Where is that? Chat program screen? That's the one. Go to the properties and hit refresh on it. Hey, Sienna Gertz. Still broken. What the hell? Why is it not recognizing YouTube? See, like, it shows up on the blade. That's all there. But it's not showing up there. Maybe it's a function of... Oh, you're the same person. Okay. That explains it. I never know with these things. It's like my cousin drops in and is like, hey, I'm Australian. And I'm like, who? Wow, another Australian is actually willing to watch my show at 3 o'clock in the morning. He's like, no, it's just me. It's your cousin again. I'm like, God damn you. It's like, I forgot my password. It's like, I have multiple family members. My niece, lost her Discord password and just started a new account. These kids in these online services, they forego their identities. 98%. This is the longest 98% ever. I like the synthesizer part in this song right here. This is one of my favorites. Not much to it, but it's nice. I like it. All right. I don't understand what broke YouTube because I'm looking at YouTube chat over here. And I'm looking at YouTube chat in this one. And the one that's on the OBS window is running the exact same software. Session expired. Please sign in. No, I don't think I will. Yeah, I just don't get it. I don't get it. Sometimes this stuff kind of breaks down. Maybe it'll just start working throughout the day, like when I'm not updating Fusion, when it's not at 98% forever. I have the 3D Puck mouse, but I don't use it. Apparently, people say it's like really good for doing CAD. I had some fun with it, but... Oh no. Hi everyone, nice to meet you. Is this a first time chat? This is a first time chat. Oh no. Ah! And then my window gets covered over. Hold on. Nice to meet you as I prepare to spend my day in AutoCAD or maybe Revit. Fusion Day. We're gonna do Fusion Day. We're doing a Fusion Electronics Day. I spent yesterday, all my precious time yesterday, the only time that I have on this earth, putting parts into Fusion. So we have all the chips and stuff. We should be able to build, we're gonna build our own puck. I don't know what we're talking about anymore. Puck? What puck? What puck? What the puck are you talking about? But yeah, we're going to work on reverse engineering, which is a lot of staring at what is going on here. This isn't normal. Hey, Fusion, you doing okay, bud? How you doing, buddy? Whoa, there we go. Oh, the space mouse. Yeah, sorry, I forget what I'm talking about sometimes. I have a normal one. I have a regular one of the like $100 ones that's just the puck. It doesn't have the little thing around it. And what's that guy? The dude who does he did a whole series on Gears, and he's got like a robot arm and stuff. He's not like one of his arms. I mean, he has a robot arm in his shop, and he does like projects. Oh god, I forget the guy's name. Anyway, he was talking about how awesome that 3D mouse is because it's what he uses for CAD, and he like assigns the buttons to stuff. I never could get used to that. It was really cool to be able to do like walkthroughs of a design and like fly around it and stuff. But generally, like just clicking with the mouse and moving your design around, and you know the whole clicking things on screen thing. This is just fine. You know what you do in Fusion, center click or shift click to spin around. I have no trouble doing that, and Fusion is really good at focusing on what you're looking at and sort of keeping the axis in a nice place. Sometimes it gets confused, but I generally don't find myself needing to have like a space mouse in order to do that. And it also takes your hand off the keyboard. With Fusion, you're typing numbers in a lot, especially if you're doing like a 3D printing kind of like engineering bracketry kind of thing. You're going to be measuring stuff, entering stuff, you know, typing in numbers, and having a space mouse puts, you know, its hand on mouse and controller, and it doesn't give you that keyboard. I think a space mouse would probably be pretty cool in a flight simulator, like a space simulator. Have a space mouse, used it twice. Yeah, mine's collecting dust too. It's over there on the shelf. Still works, but it was really cool to use in Kerbal Space Program. That's where the 3D mouse really came into handy, because I was able to get into the design and add struts internally using the mouse. God, I feel like I haven't done any like what do you call it? Looking pretty toiletry stuff. I forget. Why does my brain locks off things that I should be able to say? Why does my brain do that when I'm streaming? It's like, oh, by the way, you forgot the word for that. Why did I forget that? Let's open up the design here. So we're in m303. Streamer brain. It's horrible. It makes you feel so dumb. It really does. It's so crazy. Like the brain is a very complicated thing. It's everything to us, and it's so funny that I can just go weird. The link schematic file has new versions. Do you want to load the latest version? Yes. That's all I ever want to do. And I wanted to believe that I get caught up when the rage in me subsides. This is old school trance. This is old 90s, early 2000s trance music. I love it. I love it, unironically. This is all I've done so far, is just the 5-volt power supply, and that's not even the right voltage regulator. That's an LM117. That's not what this thing has. Thing has a weird LM317. But I put the 117 in here because I wasn't willing to make another part. Making parts in Fusion is a lot like pulling teeth, because there's just a lot of pain involved. It's just pain. But I've gotten okay at it. I've had to add a bunch of parts that have multiple pieces to them. And there's a particular way you do that, and that lets you put down all the pieces of the part, and then you can invoke the positive and negative supply for it. But one thing that Fusion does that I do not like is the LM317. Well, a couple of these are guilty of that, and I think I have the part thing open. Some of these parts are complicated, and some of them involve. Where's my window here? Not you, not you. This one can get closed. This one there. Where's my stuff? What did you do with it, chat? There it is. For instance, the where is that thing? Where does that thing go? This guy. This one has two elements of this schematic sharing a line right here. And when I draw that in CAD, what I'm going to be doing is making one of these filters. And so the spacing of these two transistors, the spacing between them is going to change. So in the part, in the actual CAD part that I'm building, I would like them to be two separate elements. Two separate elements that share a pin. And as such, I did that, and it didn't let me do that. It didn't let me do that. It doesn't let you do that. If you have more pins than the device, you can't then assign it to a footprint that has fewer pins. even though you can add 2 separate pins to one single connection when you assign the pinout. It's so weird. Is there no LM317? I don't want to use the built-in Fusion libraries because the built-in Fusion libraries are a mess and they don't necessarily have the 3-dimensional parts that I have. I insist on having 3D models for everything. Like here are all the libraries that I have. It's a lot. There's a lot of stuff here, but I only stick to my own libraries. And if I have to go outside of them, I pull the parts into my own library and I make sure that they're fully authored, because you can't trust a pinout. A pinout that works for one engineer will not work for another. For instance, I started out using SparkFun's parts, but SparkFun insists on having absolutely no space to solder the resistors. So all the resistors are compacted in, and they're very difficult to work with, I've found. Especially when you're first building a design of yours, and you put it together, and you're like, I can't solder. Why can't I solder? Why is this so hard to solder? It's because they didn't give you any room by the resistors. I think SparkFun insists on using, a stencil oven kind of process, which is, you don't need to get a soldering iron in there. But yeah, do I have a SparkFun example? I think I do. My pump on this arm? No, it's on this one. Why am I so red? What's going on there? I'm having a day. I think I'm puffy today. I think that's what's going on. I'm having a puffy day. Here's a SparkFun board. No, where are you? See how little room they have for solder there? Puffy day to you, sir. Oh no, what have you done? All right. Yeah, so the SparkFun parts don't give you any room to solder. There's like no room around the stuff. So I actually, what did I do? I imported Seed Studio parts for that, even though I could just make my own footprint. ATT is a dick. Haven't been able to call or receive calls since yesterday. Oh shit. My phone does this dance where every now and then it just goes, and then it doesn't connect to anything. So I need to restart my phone like every 2 days. It's obnoxious. But that's not AT&T. That's just Android being really bad at handing over cell service when you have very low reception. So like it'll get on the cell network, it'll get very low reception and be like, cool, I'm all about that. Even though it's got full Wi-Fi. Obnoxious. My hair is really getting in. I'm going to have to get a haircut soon. When was my last one? It feels like it wasn't that long ago. Weird. Oh, really? Restarted like 7 times? Jesus. What was I going to open up? I was going to open components. This one. Yeah, I don't know about AT&T in terms of carrier. Or no, it's chips. Chips is what I want. The one that's in use. Edit. This is a very copyrighted song. I'm glad that nobody will hear it. Had issues with baseband locking up an application processor doing fine ages ago on the old MediaTek phone chips, but nowadays everything seems to work. My Android is really bad at it. It gets really confused. My neighborhood does not get good cell service until you get to the road where all the 5G antenna are. So once you get to the road, the road that leads away, I talk about it very vaguely. Until you get there, you do not get 5G. You barely get edge like LTE. And it gets very little LTE sometimes in certain places. Inside the house, nothing. So it'll fully switch over to Wi-Fi. But if I'm outside, I get a little tiny bit of Wi-Fi, enough to function, and LTE that's not enough to function, and it flips between the two manically. Oh yeah, if you live under a 5G antenna, your phone is probably going to work properly. I wish they would fucking install something out here. I would fucking tape one to my balls in order to get 5G out here. It's so obnoxious. I feel like I live in a cave because I'm underground. But it's just like nothing works. I hate it. I don't have 5G capability on my phone. What? Get a new phone. Wait, what am I looking at here? Why is there, oh, because nothing is, that's display layers. They're all the devices. So like when I add a device, I insist on it having a 3-dimensional part. Both surface mount and through hole. What is this window? You can go away a little bit. Fusion does not like it when you're a restricted size window. Things get a little bit weird. These like do not need to be this big. What? I really wish they would try using their own program on computers that aren't the size of whatever computers they're authoring this stuff on. This should really be much larger than this. This part right here, the symbol. What in the hell is going on? Let me move this over. It's not letting me change the size of this. What the fuck? Do they not use their own program? Do they not, like, try it? Just give it a shot? All the UI elements are breaking right now. That should resize this part, but it's not. Why is that fixed? What's going on? What did it do? Oh, I can't click on this stuff. Is it freezing? It's like freezing. What the hell? So I've somehow, by virtue of doing pretty much nothing, I have broken Fusion. And I cannot resize window elements that are unusable in their stock form because I had the audacity of making my window large enough to fit on the working area of my screen. You see, I don't do this full screen program with my, my cutout in the corner. I have multiple windows up here, and I'm showing you the one monitor, but part of the monitor is locked off so that I can have chat up on screen. And that works with, the sizing of the windows and the way I've done the layout. I could obviously redo a lot of this stuff. I could sit in front of a green screen if I really wanted to. I have green screen sitting in the back, but like, this is not usable. Why is this so big when the symbol, the part that I was gonna talk about, is this sized, and now I can't resize anything? All because I wanted to have a little bit of room on this monitor to have chat up. And if I try to correct it, it doesn't correct itself. So I go full screen and I look over here for an element that I can grab and I can't. There's nothing to grab. This should be resizing itself based on this window popping out. And these two elements should get smaller. I guess I'll close this, I'll try reopening it. So if I open up the design manager, not the design manager, I want the place components. Well, that should have bumped this element over, but I guess place components is opening in like a window. That's fine. I can go to the library manager. Let's just see what it does from this view. Open up my library that I want to edit. Right click, edit. Now it opens up, but it's not showing me my content manager. Content manager is king here. The content manager is what you click on the parts assemblies with. So now I have the, let's do MCP 6004. That's 4 op amps in one. I'm going to open that up. I don't know why this is coming in as a window and not pushing things over. What is this down here? Oh, wait, what is that? Oh, that's just the, yeah, I don't need that actually. I lose this song. This song is good. I think it's because it's not opening as a thing over here. So this is all the way over. But if I do that, here we go. There's what I wanted to have happen. That's what it should be opening up like that. Now all the elements on screen are approximately sized to where I can see their features. Because this is what makes up a component in Fusion 360. You have the schematic design, you have the footprint that's actually going to go, on the PCB, and then you have the 3D elements. So this is taking that footprint and adding a 3D model to it, which I think is pretty cool. Like, it's able to render really nice circuit boards that way. And you can, your trace layout and everything is right here. You can edit these elements. You need to know exactly how to do it, or else you mess everything up. There's ways to do it. And then you have on the 3D element, this actually, well, between the schematic element and the two-dimensional element, it's got the pins all assigned in order to do air wires in the software. I love it. I love this kind of thing. This has existed for a long time. I'm explaining it like an old man just learning how to use a telephone, but still, it's pretty cool. And then they add this three-dimensional element to it as well, which helps you really take a look at your design before you commit to it. All right, now I want to get chat on screen. So if I resize this, there, everything resizes properly. I don't know why it was so weird about that before. It's a bit of a struggle bus to do that. All right, that seems to be working. Why was that element weird? Good part about KiCad is that the parts, packages, and footprints are all separate. They technically are in this, and I did mix elements. Like the power pins for this one were from, well, okay, this is an op amp, but I took these power pins and I put it into other ones too. Because when you actually make your part, you can make a footprint from scratch, or you can put in a footprint from another device. So these are all the other drawing elements of it. My only problem was that when I did the diodes, sorry, the transistors, one pin is shared between two of those, and I wanted those to be separate elements so that I could put them in, at whatever distance apart looks good, and it wouldn't let me do that because it won't let you give a package that has more pins, even though over here, where you assign the pins, if you hit connect, they bring up this whole dialog where you connect the pads to the pins. You can assign 2 pads to 1 pin, which would make 2 pads to 1 pin, but not 2 pins to 1 pad. That's the problem. And I don't know how to make 2 pins into the same pin. We could try something in a bit, but what froze so much sound dampeners on wall? It fro making no echo noise and good sound. It's, they don't do much. Mostly they're visual. They're so that we don't have a big white wall sitting behind me, and I have Twitch colors on there, and they make things look a little bit cozier. But mostly it was a big project where I bought a lot of panels and put them together. It should reduce echoing by virtue of just having foam around me, but it doesn't do much. The corners, I have not done anything on the corners. The corners are really where you kill echo. But it's to make things a little bit less resonant-y. And just to make it look cooler in here, makes it look a little bit more like MySpace. I think if I had to redo it, if I were to move into a new shop tomorrow, what I'd like to do is wood panels and LED effects. I have some ideas for that too. Just to like space out the foam tiles, and if I get deeper foam tiles, those will actually do something. You can buy better foam tiles, and so I do like wood plank, foam tile, wood plank, foam tile, and see if I could do some kind of like an LED wall sort of thing in there, so that I can have some kind of visual going on in the background as well. Like have cool stuff that the shop would do in response to my streaming. That's a project for another day. I love big LED projects, and I have a lot of big LED stuff to use. I have LED strips that I could really, do with an application for already. But it's a lot of work to put something like that together. It's not hard. I can pretty much staple it all together with ESP8266s and then have it, configurable with Node-RED. I saw a project where somebody had a Lego city, and they coordinated all the LED visuals using WS2812s and ESPs and Node-RED. It was a really cool project that I would love to check out and actually do something with. But the project queue of projects in here is both long and long-standing. It's long and old, and we need to get some stuff done. When did you start simulcasting to YouTube? As soon as they fucking allowed it to. Go for 100 days past the last VOD that I uploaded. 100 days past the last VOD uploaded 100 streams past the last VOD is the date that I started simulcasting. It was the day they allowed it. I was like, all right, let's figure this out. 100 streams. That's the queue, basically. The 100 streams is the queue that I have to fulfill. I have to get back to uploading. I majorly burnt out after uploading 250 some odd streams. I have 100 left to upload, 100 VODs to get to present day-ish. It's a lot of work, and I really don't want to do it, but I have to. So I'll have to get back to that. I'm taking a break from it for like a month, and then I'll get back to it. And yeah, everything will be fine. I'll be fine. We'll be fine. It's the work on it is like the uploading would be totally fine if I was lazy. I'm not lazy. I'm not lazy. Yeah, good to see you, Jalopy Jones. You shall incur the curse for 1,000 streams. It is. I am kind of cursed right now. We don't have a lot of viewership at the moment. But anyway, with the VOD uploads, I'm not lazy, and so I'm not doing the same description for every single video. I kind of make it a little bit more personal and talk about stuff in the information area. And moreover, what I'm doing is marking down when stuff happens in the stream. The level of detail of that I need to work with. I love this song, by the way. The level of detail I need to work with on that to make it easier on myself, because I have to use the arrow key and go through every 15 seconds of the video and see what am I doing? What am I doing? What am I doing? Okay, something funny happened. What am I doing? You know, and mark it out like that so that people watching these videos aren't burdened with having to watch a 5-hour video. One of them has like a couple thousand views, which is amazing for me. And there's other channels that can just like poop out a 5-hour video and get 6,000 views on it. I can't believe it. There we go, better mic placement. Maybe they're just more entertaining than I am. Have you thought of that, Bother? Have you considered this? Consider this, streamer. Maybe you're just not cool. Let's see. Yeah, we'll just kind of scooch stuff over a little bit here. We don't need the scope today. Womp 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 womp. Anyone watching the VOD is very confused and possibly insulted. Make some keyboard room over here. Yeah, if we could get some kind of like a merger between Twitch and YouTube, so that the super strong player but with Twitch emotes and stuff. Stream Kick as well. I can, but I don't know if I want Kick viewers in here. No insult to Kick viewers, but you guys have kind of an unhinged crowd. I don't think I want to really deal with that. I have enough troubles with Twitch as it is. The human psyche was not meant to do online interactions, you know? It just wasn't meant to do that. Wish I could find that front panel that I had for the VCO. I'll have to print another one at some point. I also need to get rid of stuff that I'm not using around here, because I'm starting to get choked by all the stuff. Yeah, we got like a couple cleanup sessions in us at some point. I was considering whether or not I wanted to do that today, but I'm feeling kind of dumpy. This heat wave has been rough. I'm wearing my thinnest shirt. I always wear a ton of layers because I'm a big fat guy and I sweat a lot. I sweat an unholy amount, actually. Once I start sweating, I don't stop. And so I always wear the undershirt because it's my last line of defense. And then I wear full pants because I'm an adult. No, I wear full length pants because I wear compression socks because I'm diabetic and fat. So I am a mess. I'm a mess. This heat wave, this not single heat wave, the second of 2 heat waves this summer, which as far as I'm concerned is just one big heat wave. As soon as we hit the mid-months of summer, from now until eternity, we're going to be extremely uncomfortable. I think there's no way around that now. Free! What to do to say what I want to say. Oh man, early rave stuff was crazy. Or that wasn't early rave. Early 2000s rave stuff. I just want to be free is the theme of this song. This is hold on. Questions? Brain. Sasha and Digweed, Northern Exposure, CD2. Look at that. Beautiful. That's beautiful. Oh, this is still CD1. Oh. We'll go to CD2 and eventually. This is 1990? Holy shit. I remember buying this CD from a mall. I bought it from a mall and I put it in my Walkman that had bump protection on it. It had 30 seconds of bump protection because it was an active CD player. It was for people who like to jog. I just didn't like to have interrupted music from bumps. I think it was yellow and had a little clasp on it. And then I got a mini disc player. I was like the only adopter of mini disc. Remember mini discs? That was one in a string of many different technologies that Sony clung to tooth and nail trying to get the monopoly on. And they eventually got it with HD DVD. Not HD DVD, Blu-ray they fought HD DVD to death. Much like Betamax. Yeah, all the format wars were awful. Minidisc was huge in the DJ scene. I didn't know that. Yeah, you could get good recordings of stuff. I used to record the local radio station, the local college radio station that was playing electronic music. I found, at one point I resurrected my DVDs and I found that I made a love song dedication to a girl who I had a crush on. I did not end up with her. Nor did she ever know that I called into a radio station in New Jersey to dedicate a song to her. Jesus Christ, what was wrong with me? I was a teenager. That's what was wrong with me. Oh, did we run out of music? They ended it on the edgy, say what I want to say, do what I want to do song. Let's find CD2. It's not in the recommendations. Where's CD2? Northern Exposure, CD2. Oh, that's the wrong one. That's not Northern Exposure. Oh, it is. Wait, we're on Expeditions. Expeditions. Completo? No. Expedentes? What the f... No. Sasha Expeditions. I can't spell that word. CD2. Geez, I've bought this CD like 5 times in my lifetime. You'd think I'd be able to play it on my stream. Oh, I see. Yeah, the tininess of the discs is nice. I don't know. There was that whole schism between digital DJs and record DJs back in my day. I'm sorry you don't own the rights. I don't own the broadcast rights, yeah. It would probably be a couple $1,000s to get the broadcast rights. There was a prog rock song that I really wanted to use, and I forget what the name of it was. It's like one of my only YouTube comments was on this prog rock song. Some rapper used it to no repercussions, and it was this great song. I wanted it to be like the Bother theme because it was such a cool, like, science-y kind of prog rock riff with drums and everything there. Oh, it's beautiful. And it was used in a NASA video. I found it on... the whatever that archive, what is that called again? No, it was one of those film reel archive sites that I found through Riff Tracks, and it's where we got Shake Hands with Danger. Vinyl's so much better to mix on as it's hard. All my friends learned vinyl mixing. I had a CD DJ for a little bit that broke almost immediately because it was new technology and it sucked. It just broke, and so I kept part of the parts. I should have kept the whole thing because those CD, like the interface is so cool looking. I really could have used it for like, I don't know, like a game controller of some kind. But I got rid of most of it. We just have one PCB left over from it. Vinyl it's really nice. You got sort of a feel for everything that's going on. Less opportunity to do sampling and stuff, but as things went more and more digital, I saw a lot of my DJ friends just basically go like, all right, it's time for auto DJ, and they just play a mix. Unless they were playing like a crowd, they would just put on a mix and just do that. But yeah, now it's all digital. You have interfaces that mimic the vinyl and stuff, but yeah, people are just doing things differently now. It's a strange world out there. But I had mini disc. I liked mini disc a lot. Just for the portability of it. I had this cool little player. And a friend of mine at the end of high school asked to buy my portable mini disc player. And I was like, dude, you do not want to buy this for me. Look at all the super glue that I had to use in order to put the battery door back on. It was like this overly complicated player. But yeah, I had a lot of cool like house mixes on it from way back in the day that I would record basically directly off of the radio. Vinyl's not hard at all. It's a skill, but not hard. You got to know how to pinch it, and you got to know how to speed it up a little bit. And then the rest of it is musical acumen and getting the beats to match up. It's a whole set of skills unto its own that doesn't really translate into the real world. You can't do anything else with the skills. Like, you can learn everything about electronics, and that'll translate into critical thinking and stuff like that, right? But if you learn a lot about DJing, you can't pinch people to sync them up better. You just can't. I've seen it. It's a hard thing to watch. My DJ friends try to pinch somebody so that they sync up a little better. It just doesn't work. I'm sorry, you've learned the wrong things in life. Why is this all over the place? Oh my God. The mess from doing all of this reverse engineering is starting to get into my head. It's starting to kind of affect me in weird ways. I'm going to start developing a Twitch. I've already developed a Twitch. I'm a partner. Oh my God. To be one of these other electronic streamers and not really have this stuff affect you. I'm going to do a cool project where everything fucking explodes today. No, we're sitting here and we're doing the most cerebral frickin' thing we can. My entire audience is going to fall asleep because we're doing hardcore reverse engineering. I just threw away a little piece of paper towel that I lit on fire. There's been fire in here before, especially when we work with lasers. We're going to clean the desk. Now, cleaning the desk is something that I do in the pre-stream. We do that when the stream starts soon. That was a long time ago that I did. I don't know, it was weeks ago. I don't know why that piece of paper towel is still sitting on the desk. Oh my God, I did it again. You fucker. Stream Deck piece of shit. I really need to get the XL working. There's a lot of controls that I need access to. Before that, I need to get my MQTT broker actually functioning. And that requires me to learn a little bit more about pods. Oh yeah, it was the anniversary of The Blob recently, and out in Phoenixville, they had a whole The Blob festival thing going on, where they play The Blob all day. I don't know why that's such a big thing. Did that take place in Phoenixville, Pennsylvania? It was on the local news. I thought they filmed it somewhere else. What do I know about The Blob? Fucking 70-year-old movie. The Blob Fest, yeah. Add some super glue, I'll wait. I wasn't willing to sell him for $100. He offered me $100 for it, and I don't remember what I paid for it originally, but it was definitely at the end of its life, the mini disc player, and it had been repaired multiple times. So I was like, no, I'm not really comfortable selling this to you. Oh yeah, well, this is also, this stream is also a survival stream. I ate supermarket sushi ahead of the stream, and it was not good. It wasn't good. There was something weird about the fish, and there was something weird about the rice was like crumbling off of it. It wasn't that it was old, because it seems that it was made recently, but it tasted a little bit like mop water. Seems like it would taste. I don't know what mop water tastes like. It probably tastes like burning, but the smell that you would get, something was very off. So we'll see if I survive this stream. In terms of gastrational distress, I feel fine. It's gambling. This is a toss violation. This has now become a gambling stream. I took a gamble on that gas station sushi. No, it wasn't gas station. It was supermarket sushi. We actually have some pretty decent supermarkets here. They make good sushi. Castration gambling. Where's the poll? Oh, how you think I have mods. You assume that I have mods. That's very brave of you. Next stream I'll have a story. And then I spent 14 hours in the bathroom. I actually wanted to make a meme. Believe it or not, chat. I actually wanted to make a meme. A heat wave meme where if I could get a good thermal image, hey, I'll get a soda from the garage, and then soda from the garage would be the picture on thermals of the can glowing much brighter than a streamer ate supermarket sushi. This is what happened to his desk. Yes, I haven't watched any of those videos lately, but I wanted a picture of holding a can on thermals and have the can glowing, because that's what happened the other day. I took these out of the garage and they were hot. Nightbot is all over it. What's going on? Wait, I gotta reload my Twitch channel and see what's going on. Yeah, what? You never sit down on a nice sweaty summer day with a hot Diet Coke? Or a hot regular Coke, just pure warm sugar. That was the whole, the tweets for the hot Dr. Pepper. Did people actually have Dr. Pepper hot? I don't think they did. If they are, they need their head examined. Okay, nothing's happening here with that. Just making sure. Yes, sure. We're doing some reverse engineering today, so most of the stuff that we're doing is digital. We're not going to be dealing with the desk a whole lot. It's going to be me versus Dave's synthesizer. Me versus Dave's synthesizer circuit. And maybe, just maybe, if we're lucky, I'll have a little bit of insight for you guys to take some lessons with. Take some lessons home with you. All right, shut up, head honcho. I need a different song. Oh, that's right, this whole thing sounds like this. A little better. Let's save this document. Oh, and then I need to open up GIMP. Let's do that real quick. I forgot that I was doing that. Open it up, GIMP. Let's go get my GIMP out of the cellar. Okay, now, how can I get, is that gonna, oh, that worked. Okay, cool. Good. So, this would be in, oh, we're in project, so I need to go to Twitch. Or stream project. Do they put that at the bottom? Yeah, they put that at the bottom for this one. Huh. Stream. And then synth. Synth. This is backwards. There we go. Synth, and then we want, what happened to the folder that I made? M303, there we go. Schematic trace. That's nice. Maybe I should use that. That's funny that that would exist in the environment that got so toxic that the Linux people can't give their programs fucking normal names. So somebody forked it to have a normal name, which Glimpse is not the best name, but it's not GIMP. So it's much better than GIMP. So I don't have to constantly be referring to my GIMP. My GIMP is so bad, it keeps crashing. I keep giving my GIMP instructions, but it just can't seem to handle them. Fork failed because the only driving motivation was the name. God damn it. That should be enough. That should be enough. Yeah, I had to make all of these multi-circuit piece parts in Fusion, which is pretty doable once you get used to it. And even just like, it's easier to make your own part than it is to find a part that already exists. That way your style is pervasive throughout all the parts. My only problem is doing stuff like this. I can't seem to assign one pin for two pads. Or two pins for one pad, I guess. It just doesn't let you do that. There might be a way to get around it, but I'm not going to try it right now. Bad sushi, stay close to the restroom. It's right over there. It's very close by. Kitchen is better software. I've heard that. I've actually heard that. Yes. Well, so same thing with GIMP. GIMP is like It works, but it's missing stuff here and there. I haven't used Photoshop in decades, so I don't know what I'm missing out on. It's just that like a unity of the design is a little bit weird in GIMP. And you can't make shapes. It's strange. This is where we're working today. This would be the oscillator portion of the circuit. There's a lot of weird stuff going on here. Like, I don't know why we have analog, digitally controlled switches. I think that might not be what we have. I think that might be a different part. We may need to get to the bottom of that today. Yeah, I have CS6. Is it 6 or 7? I think CS6 is what I have. I do have that, and I need to get in touch with a buddy of mine to get the password again so I could install it, but and then start editing video again. I think maybe I want to look for like one of those cheap video editing programs, like the ones that like DaVinci Resolve or whatever. I'm not sure though. Create a library for Fusion for all the JLC pick and place parts. Start and then I get bored and scrap the idea. Yeah, you need to have like a specific process for making parts that you follow every time. Otherwise, Fusion will bite you. It like hates custom parts. But that's the only way to survive, is by making your own set of parts that you use in your own designs and sort of cultivating that library. And I've been working on that for some time, but I feel like I need to, like, one day, I just need to like pack up Stream and say, listen, I'll be back in 2 months. And at the end of that 2 months, I'll have spent all of the time to make every single part that I commonly use. Blender is a cheap video editor? Yeah, that sounds like a pain in the ass. Blender does not stay in its own lane, huh? Maybe I can get Blender to do spreadsheets. It's like Excel. So many people use Excel for so many different things that it's too much. It's like this big monster. You can do so many different things with Excel that it's not supposed to do. You can write programs in Blender, why not Excel? Can Blender run Doom? Yes. Can Doom run Blender? Do spreadsheets in FreeCAD? I've been using Google Docs, so I'm training an AI to do mundane tasks. I hope one day all of the fuckery that I do online can somehow make AI fail in some facet of its deployment. Somewhere, somebody's going to ask AI an important question, and it's going to get it ever so slightly wrong because I fuck up almost constantly online. That's all I do. Maybe someday that influence will make its way into the supercomputer brain that has enslaved humanity, and it'll cough or something like that. Why is my computer coughing? Should we get started? Probably should. There's a lot of work to do. There's a lot of work to do. Also, this song's starting to really get on my nerves. Even before the drop. I'm just going to kill it before the drop. Nobody will hear that now, from now on. Nobody will ever hear that, because the music is forbidden on the internet. Hi. Oops, hold on. It is an absolute scorcher out there. We need to do something that's not like super duper crazy. People have asked me recently, well, people have feigned interest. No, people have communicated interest in seeing the process of reverse engineering, and it's something that I did for 10 years. It's something that I don't do a lot of. We've done a little bit of it, but we've got a really nice opportunity here to reverse engineer something sort of nose to tail, and really get to know how this circuit is put together and functioning. We have an M303, this thing right here, that is broken. These things are notoriously easy. This is a modular synthesizer module. I don't think anybody here is unfamiliar with it, but for the VOD watchers, this is a modular synthesizer voltage-controlled oscillator. And this voltage-controlled oscillator basically takes voltage signals that control it. You know, the language writes itself. And it makes different frequencies of noise, and then it puts it through a filter. And it does this in a manner that is consistent with the TB303, the acid house synthesizer. Possibly that's what we were just listening to on the pre-stream music, is a little bit of early 90s trance music, and I think they used a little bit of the acid house synth, but you'll find the M303 sound being signature to a lot of acid house. It does a good job. It makes some cool sounding noises. This thing broke because it was way too easy to plug the power in wrong. You can see that these are just bare headers with no shroud over them and no explanation as to what exactly they are there for. Nobody's talking about these things, right? So basically, this thing was plugged in wrong and it broke. Acid Labs, the Germans who redesigned the 303 to be a modular synthesizer module, Acid Labs ran into this problem so much that they even had a PDF that details what parts to replace on the PCB. And we got a hold of that PDF a little bit too late. And what I mean by too late is that I had enough time to try to start testing this thing, and I was so stupid that I plugged it in wrong. And I blew it up in a particularly unique way. So now we have replaced a lot of the different parts. Acid Labs tried to keep the identity of the parts from us. They scratched off some of the numbers. They did a lot of work to, get modern parts to build a 303. A lot of the parts that built the original 303 are discontinued. They're impossible to find. So if you're going to manufacture a new module, you need to find new parts in order to do that. Now, you can still find 303 parts, right? But you're not buying them on an industrial scale. You're buying like individuals for like $10 and $14. If you're manufacturing a product, you're going to want to be able to buy them on an industrial scale. Couldn't do that. They had to redesign parts of the 303. That being said, they also had to redesign the 303 to work within a modular synthesizer. So they had to have certain input and output levels that control the elements of a 303. So a lot of their own design went into that. So that is to say, like, our effort in reverse engineering this is in no way going to be profitable to me in that regard. I'm not going to be selling like a 303 equivalent or anything like that based on the Acid Labs design, because it's not my product. But right to repair and all that jazz, I would like to be able to repair this thing and get to know it a little better, right? So we're going to be putting all of the schematic elements of this into Fusion 360. So in the future, if I want to, I can cater some of the components that I'm putting in here to my own nefarious purposes and possibly spin up a PCB that'll be able to build a 303 equivalent. I think that would be a lot of fun as just sort of a side project to do. But in doing so, it's also teaching us a lot about analog electronics and how these things are structured and put together. So today I'm addressing things that people wanted to see out of my stream, which is the sort of the hardcore process of reverse engineering. This gets to be a little bit much, but we're diving deep into the circuit and we are creating a schematic that represents exactly what's on this board. And so there's a tedium to it, there's a process to it. We're going to try to get to the bottom of all this and figure out what's going on this board. Like, why isn't it working? Because I've tested every single transistor on this board that I could get my grubby little mitts on. Right? I bought a transistor tester and tested the transistors. Because why would you buy a transistor tester and not test all the transistors? But I did, and they all work. And then I went in to build the working document, our notes, and put schematic symbols on top of all the transistors. And doing so, I had to test whether they were NPN or PNP, and all of them test fine. The transistors are generally like a weak element when you power stuff up wrong, right? So if you put too much current through the base of a transistor, you can blow it up. And that does happen. A lot of these were blown up and replaced. But the replacements work. Everything works. This doesn't work. Why? What's going on? So that's part of what we're trying to get to the bottom of. In the whole scheme of things, like Forest for the Trees, what I'm doing right now, first of all, is avoiding an extremely hot day by sitting inside and working on little electronics projects. Two, what I'm doing is I'm trying to get a working document of exactly what's here so that we can go through piece by piece and make sure that each element of this thing is functioning properly and we know what can go wrong and where things are so that we can track down what's wrong. There might be a broken trace on this thing, right? It might be one little tiny broken trace, and we might find it when we're probing around on this thing. Although we did a visual method for finding where the traces are. We're not probing, piece to piece, and it might come down to that in the end. This has been a fight. We've been fighting to repair this thing for months. I'm not willing to let it win. That's why we're still doing streams on it. Your streamer has a problem. This is my white whale. I have to get this thing running again. And then when I get it running, Dave will be completely oblivious to all the work that we've done on it and how much of a hassle this thing has been. It's really not worth tallying our hours on. What this is an exploration and sort of an education on how to deal with analog electronics more than anything else. Less so repairing a 303, because at this point, I would start just replacing stuff until it works. In this case, we're trying to learn a bit more about the circuit. So this has been a nightmare. Anyway, so in the process of doing stuff, the first thing is working from pictures was a big deal from where I used to work when I was doing actual reverse engineering. And when you're working with pictures, you can either sit here and highlight traces from point to point. You can get a printout and take a highlighter and go over the traces. You do a little image manipulation in order to turn this into more of a contrast. What I do is I actually take the top and the bottom of the board and I overlay them on top of each other so that I can jump from bottom to top and mark out where all the layers are. So now I've got these highlighted traces, just using, you know, the pencil tool in order to show me what is connected where. And we have actually been working on this thing for so long that I've removed the chips and marked out all the traces under them. Of course, the first thing you do when reverse engineering something is you look up the chips. You look up what the components are that are making up the circuit, and that can inform you on what sections are where or what precisely this thing is doing. Now, this is a beast of a circuit. This thing is not performing a simple task. Sometimes you have things that perform a simple task. You look up the chips and you go, okay, I know exactly how this thing works. Well, this is multiple sections coming together to build multiple different functionalities out of a very complicated structure. A lot of what's going on here, at least in terms of the I/O, is it's translating it into modular synthesizer voltages, and it's protecting the circuit against anything that can come in from external and harm it. Although nothing was done in the power, V plus and V minus are directly routed, which is a big faux pas when you're doing analog synthesizers. Well, when you're doing digital synthesizers too, you don't want to, listen, the user will plug a ham sandwich into that power plug. You do not want to allow them the amount of rope that they can hang themselves from. So you put diodes on the V plus and V minus, and that blocks the flow of electricity in the wrong direction. They didn't do that. And so giving you, you know, your second line of defense is the physical. You would have a power plug, what resides in a shroud with a keyway. Keyways are bumps that are keyed. They key to your connector so that if you try to plug in the wrong key, it doesn't plug in, right? But if you put it in the right way, it plugs right in. That will prevent you from bad voltages. What Acid Labs decided to do, and it's another thing that I cannot forgive them for. Where did that cable go? Where did it go? Where's the cable? Hello? Oh, it's over here. Yeah, what they did is they provided you with an IDC cable, insulation displacement cable. That's what these square flat cables are. This little square flat cable. But what they did is they give you a special one that has cutouts on the sides so that you can plug it in at any location on a square header. And then the power plug is a square header with extra pins, because if you're using Acid Lab products, you can daisy chain them together using their stuff, and you can have a control voltage that's sent internally across all the synthesizer modules. Cool, that's a great feature. It's really worth having a plug that you can plug in wrong and blow up your synthesizer. What you're supposed to do is you're supposed to plug in this power plug off by 2 pins. You plug it in off by 2 pins, and then it's able to provide power on the appropriate trace, which is just mad. It's just mad. And there's no markings to tell you that. You can look it up online and they'll tell you how to do it. But those are some decisions. That's what that is. Some really ridiculous decisions there on their part. So they made it more than easy to plug in their module wrong, and there's no protection on it. So with reverse engineering a circuit like this, where we are right now is that I've done a lot of work in order to make my job easier. I've taken my brain out of the equation in some places by having markings for where all the traces are connected, and then also having pictures of the different chips. Now, I wouldn't do this with everything coming over to my desk, because, you know, above all else, throughput is very important, and getting these things done on time is more important. Sometimes you would have same-day priority devices come in and you have to build a schematic for those. Sometimes they were high priority because they were unique, and so you'd have this thing that you don't know what the schematic should be, and you have to come up with a schematic for it sometimes I would just brute force, go part for part, section to section, and just throw all of that up onto the computer and then rearrange it and rearrange it again and rearrange it again in CAD. Or you'd start with a notebook and you would take down notes of what the structures were. You would just put the components down and just show all the connections that you can, and then you'd clean it up in your head over and over again. The advantage to this being a TB303 copy, because that's what it is, TB303 copy, that's what Acid Labs did, and they admit to it. It means that the working documents that make up the TB303 we can use in order to reverse engineer the M303. So we know that Acid Labs started from here. So the structures that we see here are going to influence what we put into CAD. I don't know what the hell this freaking thing is here, though. This 4174. Hold on, I want to look up this 4174 data sheet. 4174 data sheet. 4174. Oh, it's a plug. Hold on a minute. CMOS hex D flip-flop. Huh. I don't know if we have a type D flip-flop. I don't think that's what we have here. This is going to be tough because we need to figure out where we're... Like, we know all about the filter, right? We spent plenty of time on the filter. The oscillator I have not spent a lot of time on. From what I understand, over here, we have some structures that we can trust where the oscillations are coming from. So, like, down here, I would assume that the two transistors facing one another are sort of the beginning element of our oscillations. And those oscillations will then turn into a sawtooth and a square wave with a pompadour. The square wave on the TB303 has a little pompadour on it, and I guess that gives it its signature sound. So where to start on something like this? You come in and you take your brain out of the equation, and highlighting traces in photo manipulation software is one place to start. Putting all the components and the connections down, carte blanche, is another place to start. Although sometimes that gets more confusing and it creates more work. In the case of this device specifically, what I've done is I've highlighted all the traces, we've worked with the circuit a little bit, and now I'm going through section by section and I'm crossing off the stuff that this is in its own unique layer, I'm crossing off the stuff that I've already done. I started with power, and since power comes directly into the device, that wasn't that complicated. It almost would garner not doing if they didn't have this second supply up here. So I figured out the second supply and I got that down into my CAD software. So now we have all of the power stuff in this drawing. In addition to, because I'm doing it in Fusion 360, part of the process, once I discover what all the chips are, I need to get equivalents of the chips into my library, because Fusion library stuff is like pulling teeth. It's like pulling teeth. Fusion and their libraries, they really need to work on that facet of the software. Now, I think they have been. I think Fusion team has been actually working on that part of the software, because if I go to edit these elements, like the drawing for this symbol in the schematic, if I go to edit that symbol, we can just directly edit it. Let's just go into there, component manager, and then we're going into the symbols, and let's just say I open up this one. This one's just a little Zener diode. One thing that I noticed showing up now is if I draw a line, it has, you can barely see it. You can barely see it, but there's a little blue marking that you see in the sketches for Fusion 360. That little line with the hashes coming out of the side, right? The Sydney Opera House looking symbol, that means that it is vertical. So it wants me to constrain that line to vertical. It's showing me that it wants me to do that. And if I pull it up in parallel with something, it'll draw a dotted line over to that something sometimes. Hold on, if I do, like, see, I've got a little box, a little light blue box around this. Now, you can't go in and control those elements like you can in a Fusion 360 sketch, but the fact that that's popping up now tells me that they are trying to pull Fusion 360 sketch elements into the symbol and footprint creating parts of the program. Because Fusion 360 is an extremely powerful and simple to use. It's easy to use and powerful sketch tool, right? That tool is amazing. We've done a lot with it in terms of building three-dimensional solids. If I can do my two-dimensional board layouts and stuff using those same tools, I will just be happy as a pig in mud. Like, that'll just make my day. You see that? It's trying to lock things in and give me dotted lines. Didn't used to do that. So that's a really nice feature, and I hope to see it expanded on in the future because it makes this part of the process that much easier. This part of the process sucks. It's horrible. All right, I'm going to close the sketch manager. Hopefully we don't need to, or the parts manager. Hopefully we don't need to get into that too much. So yeah, first things first, figure out what's going on with power, get all of your components in there, and then you can actually start working with the schematic itself. So that's where we are. I've done the power stuff. It was too easy to do. There are some missing components, but I don't know how I want to mark off missing devices, because there's up in the power supply. Why did I do that? Up in the power supply, there is hold on. In this silence. I'm gonna cough. Oh my god. So I have what looks like a transistor right here. If we just get remove all the slop. There are a couple components that haven't been populated in this board. One of them here looks like a transistor with the two lines shorted. That might mean it's diode. It's a specific type of diode, but it's not in there. And so I didn't mark it in any way on the schematic, but it's worth noting that they might have had a different power supply scheme in mind. Okay, so I did the power stuff. It was too easy. It took me about 5 seconds to do. We still have the routing of the power all over the board. I haven't marked down where all that stuff goes because we haven't even started yet. I think that the place to start, and this is pretty confusing to me, is with the oscillator, because everything starts at creating these waveforms, right? Where are we going to find a good start? I mean, there's this flip-flop over here, but those are some of the control elements that have been completely changed. Oh, great. And then this freezes. All right, I brought it back. So over here, we've got some kind of a thing going on in order to control the oscillator. I don't know what that structure specifically is. We're flip-flopping something, and then we're putting it through a 4050 IC10. What is IC10? This thing breaks out what all the ICs are, so we can maybe get up here and tempo control. Oh boy. IC10. See, we're starting here at the VCO, but what was it, a 41? Man, okay, hold on. 4050. 4050, okay, this looks kind of familiar. MC14050B, a hex buffer. Of course, we have an inverting hex buffer, but hex buffers are a way you can make oscillations with hex buffers. A 4050 coming in from a flip-flop. I'm wondering if 4174... I'm wondering if this switch... I keep going to the wrong camera. I'm wondering if this device right here is not, in fact, an analog switch and is actually some kind of a flip-flop. We'll have to see where the components come out. And, I mean, power looks like it's going in the right spot, but... So, okay, so of all the things that we know about this board, we do know that the waveforms are pretty much finishing down here. That's where the waveforms eventually go. So they're coming from over here. All this nonsense. And in all this nonsense, we do have two transistors that are facing one another. The bases are facing one another. And so I think maybe we start here. Because in the TB303, our oscillations are coming from two transistors, quote unquote, that are facing one another. Another element of it is like, what the hell are these things? 8, 9, 10, and 11. What are those? I saw those elements in the, what was it, the 4017. What was the part number for that thing? This was the 4016, sorry, 4016. Let's open up the data sheet for that. Pinterest, what the fuck? Even data sheets are getting destroyed by... No, this is 4016 data sheet. Quad bilateral switch. In one of the data sheets, I actually saw that symbol. Was it the Fairchild one? Oh, that's different. They kind of show you what the diagram of that is, and they use that symbol. I'm not familiar with this schematic symbol. That's why I want to look it up and see what it is. Rev C. That's a little different. Yeah, one of the data sheets for this thing described it as looking like that. Can't find it. All right, anyway, it's like 4 triangles going into each other. This says it's IC12. Does it give us any other indicator of what that is? I don't think they call it out by IC up here. Type D flip-flop. There's the block diagram. Binary decoder. Hex flip-flop. Hex Schmidt trigger. Weird. What is that device? Here we go. Quad analog switch, quad multiplexer. That's what it is. Okay, then. So I do have the right part. Isn't that weird? It's a very strange part. I don't know what it's doing in the schematic. Well, in this system. We'll start around there, but I mean, like, there's this whole element of the flip-flop doing something, but that's in response to signal flag 1, 2, 3, comma 5 and 6. 1, 2, 3. I don't know where comma is, but 1, 2, 3 coming from PD650C, which is some kind of a, well, what is that? Is that might be a microcontroller? Yeah, it's got a clock going in. It's got a coil clock. What the hell? Wait a minute. What is this accursed thing? Yeah, we've got switchboard microcontroller output, which this thing, the M303 does not have a microcontroller. It's not a sequencer of any kind. It doesn't need to have a brain. So it's just the oscillating element of the M303. So pins 1, 2, 3, 4, that is not really needed, but I guess that means we don't need the flip-flop. We still have the inverter, and then these are switches, apparently. What in the hell is going on? Okay, well, let's start with the transistors and move to the switches, and we'll just see what this thing looks like. What I'm going to do is put down parts informed by this circuit structure, but I don't think it's going to follow this circuit structure. I don't think we're actually going to get exactly what we see here. We've noted that the Germans did copy this design very faithfully, and they're getting the same functionality out of very similar components that are structured in very similar ways. Like this matching pair over here is going to be an important facet of the oscillation. But getting things... Oh, another additional thing on this. This schematic diagram was built in order to inform somebody who's fixing the device, and the circuit elements are not necessarily being put together in a way that is necessarily communicating what's going on. If we have an external control, they're pulling it all the way over here to say, oh, it was on the front panel, which I'm not going to do. I'm going to put these local to whatever's going on so that we can get a little bit of a better idea of what these circuits should look like. And then we're going to have to Google. We're going to have to just not carte blanche. I keep saying blank check. We're going to have to Google elements of this thing in order to figure out whether or not we should be arranging our structures in a particular way. So like a Schmidt trigger, what do you call it? Analog mux oscillator is something that we might look up in order to maybe find some circuits that explore the concepts that are in these things. Whew, how'd I do? Is that all right? Okay, so I hope this is getting across to people. I know it's background noise for some people, but those who want to know a little bit more about my thought process going into this can be well informed. So I'm going to have to find a place to start. There's no logical start point for this whole business here. I could potentially take some of the inputs and trace it from the input and put like, what is it? VCO in, like CV in. We could start there as sort of a logical input. And that control voltage in will then lead to frequency control. Yeah, maybe we should do it that way. Let's try that. Okay, so we start from CV in. CV in comes in on the front panel. This has a front and a back panel. If I were to make my own, I think the challenge would be to make it without two PCBs, and do it on one PCB. That would be a massive challenge. So we need our CV input. Which one? Where does that come through? Voltage controlled filter in. V cane envelope. Voltage controlled filter. Voltage controlled filter. So that's in CV and mod. That's VCO in and VCO mod. So VCO mod. Or is that VCF mod? I don't think that's VCO. Well, maybe it is. VCO in is coming in through here, and it goes through a potentiometer. That goes to ground. And then that in gets adjusted, and it goes to that pin. Where it has no connection to anything else. What? Wait a minute. Oh, bottom layer. I'm not looking at the bottom layer. There it goes. Okay, so let's start off with that. What potentiometers do I have? I'm just going to use the mutable instruments one. And we're actually going to start it on a different page. This page should probably be reserved for power structures. And maybe I'll put in all of the power of the ICs on one page. I don't like doing that, but I guess I can do it here because they all have decoupling capacitors on them and stuff. So as we go through the design, I'll take a look at where power and ground is, and I'll add them to this page. So we'll start off with our front panel, and I'm going to go ahead and go to page 2, which I've already started here, and this is going to be where our VCO exists. So we'll start in the upper left-hand corner, and we'll generally work our way down to the bottom right-hand corner. Now, a lot of that's all well and good to say. My ears just started ringing. I just started getting ringing in my ears. I think that's that sushi that I ate starting to attack my body. Upper left, lower right, just like if you're reading a book in English. That's not going to necessarily hold for the entirety of this reverse engineering session. Obviously, as I pull stuff down and I put stuff into schematic form, everything's going to be a huge mess. And generally, we're going to go from an upper right to a lower left. Upper left, lower right, sorry. But yeah, that doesn't necessarily work out all the time. That's a pretty loose rule. It's just there to kind of help us understand what goes on. So, all right, let's start off. Let's get a part in here. So we're doing place component, and I'm starting from my own libraries. So I have connectors generic. Actually, I think it's a specific connector. Let's go to specific connector. And I already have, from all the mutable instrument stuff that we've been doing, a TRS. That's not the right one. That's the horizontal one. What is that one even doing in here? It doesn't have a 3D model. Somewhere down here, I've got the... Huh. Am I using the wrong library? Because I should have the... This might be the wrong library. TRS, SMD2, audio, TRS, TH, those are weird connectors. This might be the wrong one. Version 69, maybe it's a generic connector. Those are headers. Don't necessarily have models for all those. Let's see here. Yeah, this might, hold on a second. It wouldn't have been a component. Would I've counted it as a component? Let's check components. No, 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 no. What is it doing? Oh my God. All of my arrow key inputs are coming in. It's not going to let me do anything until it's done. Okay. Zener diode, SMD fuse, resonator, PTCs, MOSFETs, LEDs, indicators. Yeah, I need to clean up my my libraries. Because somewhere in here we have a perfect jack, and it should be in either probably specific connectors. And somehow there's a later version than the one that I'm actually using. And then here's the one that I should have over all the other ones. What the hell? What is going on? Chips managed, yes. It's the larger version numbers that I should be using. Neither of the components? No, version 42, okay. This is a mess. I really need to clean this up. Schematic, version 6, modules, version 42. Those should all be the appropriate ones. So where did my... Oh, version 15, version 69. That is the wrong one. Let's check version 15. That is fewer things, so yeah, it's definitely not... All right, where did that component go? Mechanical is like screws and stuff, right? Ah, this may be where it is. Yeah, Thonky Kong. I don't know why that's in mechanical and not connectors, but all right, so we're starting out with a Thonky Kong. I know this thing doesn't have Thonky Kong connectors, but we're doing modular synthesizers, so that's generally, you know, what I'm using. And there are different spacings for the different Thonky Kongs. I don't know which one. I'm going to go with whatever has a 3D model. There's two of them. One of them pulls that pin, that floating pin that can move back and forth. One of them pulls it in a lot more than the other one, and I had to do a little bit of editing on the 3D model for it. But we'll just start with that. We can always swap the physical component later. Double click, into the design it goes, and then we center click in order to mirror it. So now we have the tip contact here and the cutoff contact in the middle, and the bottom one goes to ground. So we'll start off with that, and the connector on the front panel, I didn't map it, I didn't do pictures of the front panel, but I know sort of generally that all of these go to ground, and then the output will go, you know, to the specific stuff. We also have a potentiometer in here. Do we know the value of that potentiometer? I mean, I guess I can put it in for posterity's sake. The one that we're looking at would be the VCF. Well, that's control voltage in, and then I guess it goes to slide in. No, that's an input for slide. Does it go to the tune knob? That would be a... No, tune knob does its own thing. VCO... Oh, it goes to the VCO mod. So that's this one here. And that one is... How many K? I guess I don't really need to mark down the value, but it's, you know, while we're here, I might as well. Is it marked in any way? Man, my right ear is ringing. I don't know why. Some light on that. It's like a perfect C note. It's just E. 50K. Okay, so that's a 50K potentiometer. So go back over to here and do some schematic elements. Whoa, yeah, let's put in the pot. So we need a pot, Alps, not the button. We need the, nope, pot US. We need one that actually has a thing on it. So vertical, and then one of them is a little bit restricted. These are different widths of the pins of the pot, which is weird, but whatever. All right, so we'll put in the vertical PS4. I don't know. This one is 50K. I guess it's already up to R4. And then this goes to ground, according to what we see here. These are my notes from the front panel. They're very sloppy, but we have our input going into the mod, going to ground. And I don't know what the cutoff pin is doing on that one. We can just take a quick look and see what that cutoff pin is doing. When you plug the plug in, it'll cut. This is the same way that they're able to route stereo to like speakers and stuff. This is the wrong side. We're all the way over here. Oh, that may mean that I was looking at the wrong the wrong pot for this. Is that one a 50K? Hold on, let's quickly take a look. That's a 50, right? Yeah, 50. Okay, 50K pot is the first stop of, so ground, wiper, end of the thing. That goes directly into the input right next to it. And the cutoff pin is this one right here. That goes to ground. That's an important data point. Basically, see here, we have a signal that can come in here, and if we plug something into this one, it'll cut it off and instead route it over that way. Why am I looking at the second one, though? Why is the second one here? This one is VCO CV. We're looking at CV in, not VCO CV. I guess we're starting at VCO CV. All right, fine. VCO CV. I need to put like text next to that. Well, okay, so this is VCO CV, and that center pin goes to ground. So I need to go to my schematics library, and I'm just going to put in a ground. That, and another one over here. And now we can connect this element to this thing, like that. Or no, yeah, like that, and then also here. So there, and then here. And then I'll take this up like this. Just make it as small as I can manage. I'm willing to give these two separate ground pins. It just makes it a little cleaner than running them all together. And there's our input. Wait, that's not how it goes. That's not how. Wait a minute. Wait a minute. Other way. Delete. This needs to go down. Oh no, it's still in the, it keeps you in the tool. Let's double check what's going on there. It goes from VCO CV that would normally be connected to ground. It now routes that pin to the edge pin, and then the wiper goes to the next layer. It goes to the next board. Okay, so we have that backwards. So actually, I'm going to grab this part and center click to mirror it. This needs to be in a better spot. Put that right there. Okay, so that, actually our grounds should probably stay a little further apart. So, and then we'll take this down here. Whoop. Just like that. That connects like that. Okay, minimize this. And that's as small as that's going to get. Okay, so there's our VCO CV. So I need some kind of a note there that tells me what that is. How do I do that in the schematic? I think I document, and then I can put this down and do VCO CV. VCO CV, what layer are we putting it on? Info, guide, I guess guide. All right, whatever. Now it's starting to look like, it's looking weird to me. Okay, VCO CV input comes in from there. Normally it's connected to ground. Ground will give you just like a middle note. Or no, that's VC, yeah, I guess so, weird. What's that? My brain wouldn't rest until I found what intersecting triangle symbol was called. We were gonna get to that eventually. Thank you for looking that up. It was called what it's for. It's called a bow tie, and it's for a transmission gate made up of two MOSFETs. Bow tie, all right. The originality of electrical engineering nomenclature is forever enigmatic. So this is going extraordinarily slowly, and that's because I'm explaining to you guys every single thing that's coming through my head. You can see how things are coming in from like an effervescent cloud of ideas and thoughts and nomenclature and techniques and references that you're just plucking stuff from in order to get this stuff onto the page. In addition to that, you get into the head of the person who originally designed these things. We haven't quite gotten there yet, but we do get there eventually. you know, as you go. It's just piece by piece, and we're just going to inchworm our way from input to output. And I'm not really sure if I should put in the VCO input on this as well. That VCO input, what happens to it? Where is it going? So VCO and then slide. So VCO is coming in on this connector right here. That connector right there, we know that the output is that top pin. There's also the bottom pin coming in as well. So that VCO is pretty much just routing directly to this plug. And then slide is over here. Slide goes directly to the plug as well. Otherwise, slide input is connected to ground. I don't know if I want to mark off every single input. God, there's so much to this circuit. There's so much. All right, let's not get overwhelmed. So VCO comes in. That's a VCF. Gate in, accent in, decay, volume. That's accent. I don't know if that one's VCO came in. Which plug is this? This is the one. This would be on the lower left because this is flipped 180 degrees. So it's actually the lower left, and it comes in on the most inboard pins. So these pins over here. So yeah, there's CV input. I thought we were over here. VCO in. Yeah, there's slide and there's CV. So CV and slide are coming in right here. So I wonder if we should do slide and because those seem to come directly into the area that we wanted to work in. Although this one jumps all the way over here. What's going on with that? CV in goes here. Okay, let's change gears and let's move this. I'll move this elsewhere because it'll become relevant soon enough. Move it down, and then we'll do the same thing again. So I'll put in the same parts. Throw ground in there that we can work with later, and then we'll go over to mechanical, which for some reason has all the plugs in it, and go to the same. Well, we don't have a pot yet. We have instead a Donkey Kong. Do that, put that in right there, in the upper corner of our schematic, and then we have another input that's slide in, and we'll just put the ground aside for now. Actually, we can ground these as we see fit, but and then we can do on the document layer, guide layer, CV in, CV slide in. All right, get those marked down. Get a ground over to this. And then CV, oh wait, we're in the wrong layer. What is the normal? It's nets, right? That's where you normally put traces. I think so. Just double check on the other sheet, or just look over here. M3, net class, properties, length, angle, width. Where's my layer? I guess it is just a layer, okay. Yeah, same information. Okay, yeah, nets are where we put normal traces. Okay, let's see here. CV in comes in from over here. CV coming in here. It goes directly to the header. It is also connected to the header on another pin. Slide connects to ground normally, and it goes in on another pin of the header. So on the slide pin, we can do one of these things. Copy the ground pin. Copy that, put that there, and then we can connect it. Design layer, put a net in here. Oh, did I put in a non? Are those not traces? Those might not be traces that I put in. Uh-oh. Go and correct that. I'll just delete this. Delete this. Okay, and then take a trace and put that in there. There we go. Now I don't have to worry about layers. Haha. Okay, we don't necessarily need to mark down that these are going through the front panel. I'm not going to bother to do that. If I did, I could probably just break up the header into individual symbols and just put them there. And then it would be like a broken up device. Instead, let's take them to where they go. Jeez. Language words. So, slide in goes there. CV in has the 2 pins, and I've marked down which one is... my symbol changed. That little hook should probably be the tip. Let's double check that and just make sure that my nomenclature... because my nomenclature is going to end up confusing me in the end. That's the wrong one. So yeah, CVN pin, which is this outer one here, goes to the first one. Why is that? Hold on a second. That one is the one that's closest to the outside. I've got some issue here. I think we're barking up the wrong tree. Something's wrong. So this, you can see, there's my piece of stuff, my piece of tape that's anonymizing this board, and it's up top. And if this plugs in to this board, and these two line up where everything isn't off, that lines up like that, and so that thing is up top, and our 2 pins are down here at the bottom. Oh, I didn't get the other light in here. Let's get this light in here. We'll get a little bit more ability to see things. So I got to line these up, right, and plug them in properly. And then this is upside down. So here are inputs that we're looking at right now, and they go to this pin header. And they go to, oh, they do go to the inner part of this pin header. Okay, I'm not crazy. I'm actually not crazy. So these are correct. And I'll look at them upside down. Maybe that'll help us. Actually, viewing them from the front is probably the way that we're supposed to be looking at them, but we'll look at them all the way down here. And so this one is slide in, this one is CV. CV goes to the bottom one, and the pin that cuts off goes to the outermost bottom one. So for some reason I did that as like that. I don't think that's really correct, but now I know the identity of these 2 pins. Okay, so we're tracing the one that gets connected to the pin. The one that doesn't get connected to the pin comes from here. Where is that going? To the input of an op-amp, a non-inverting op-amp? So when it's not plugged in, the control voltage is coming from over here. And that would be connected to, not VCF in, because that's not what's on that layer. You guys can kind of see what I'm doing here. Tracing this one, and it goes under VCF in. If I take out the okay, so we're just tracing it along up here, all the way up. Ah, that goes to the CV input of the front panel. So above pin 5, there's CV in, and that goes to our front. So all I'll do is do a line that says CV on it. And that gets cut off if you push a plug into it. So this one here, and we add a name to it. Oh yeah, we need to put a label on it. There we go. We put a label on it. I hit Alt. I like to separate the text from the label, and then I need to change that. And 5, and we're going to call this CV. It's going to be like, hey, you want to connect that to, oh, it already exists. Use the name. Okay, so we need to use a tool. Name CV. There we go. So that's CV input from the front panel. Which I guess is a float when you don't plug anything into it, which is no fun. You definitely want to plug something into your VCO. I'll move it out a little bit. There, that looks good enough. Okay, so now we're cooking, right? We're now on our actual input to this synthesizer. We're going to follow our trace. That's good. We uncovered one little piece of functionality. So if you had another device that was using that CV pin, which is a common thing, above 5 volts you get a CV pin. If something else was coming in here that uses that CV pin, you could then send that CV into this VCO, and that would control the VCO. I guess there's no way to cut it off in the synthesizer either. So if you were using that CV, no matter what, it's going into the VCO, unless you plug in something external. That's strange. This thing kind of takes over the functionality of that pin. That's a little rude. That's rude. Okay, next we have the actual CV signal going into everything else. So that's coming from this pin right here. And we're going up and around, over, under, and we're going into the plus symbol of an op amp. So I need to get this TL07.2 onto my board. So now we go to Fusion, and I'm here, and I place a part, and I look at components, or chips rather, manage, because it's a chip. That's how I organize things. I don't know why. TL07.2, which, you know, maybe later I could make that at 4, but TL07.2 package is just the surface mount one. Double click, and then we add it in here. Let's give it a little, well, it actually has a little bit of space, so we can actually add it pretty much right here, and we'll make that do its thing. Off board, I'm going to put the B, and then I'm going to invoke power plus minus from this chip. Actually, no, I'm not going to do, well, should I invoke that here, or should I invoke that elsewhere? I don't know how I can invoke it on another sheet, so for now I'm just going to do invoke, and I'll put it on this sheet. So those are the power pins for this specific IC. Pins 4, pin 8. What's up, JJ LaBelle? How's it going? We're doing a sort of full force reverse engineering of this board. So we have our CV pin going into our positive pin on this TL07.2. We have all the other stuff for the TL07.2 that we're going to work out in a little bit. For now, let's just work with it like this, and let's figure out what the structure of this thing is. I had somewhat dubious supermarket sushi before stream, so what's happening here is that we also have unity gain across the amplifier. Wait a minute, let's double check where that's coming from. So we're coming from this pin, because we know this one loops around the board and goes all the way back up. So we're coming from this pin here. And actually what I can do is on my done layer, if I can get my done stuff over here. Let me eyedropper that real quick. This. I actually don't want to mark it as done until I've actually finished working with it, because it'll ruin my view of that area. So I'm not gonna mark it down, but I could highlight this as we go. But we will just be responsible and follow it. So we come up here, over, up to there, to here. We jump over to here, and then we immediately go to a 1004. So that's 100. That's 1M to ground into what is ostensibly the positive input of this op amp. Now, are we sure that this isn't flipped 180 degrees? That could be a possibility, and if it is, that would mean that we were going into the negative, and there would be a 1M, but that goes to ground, so that doesn't seem quite right. but we are going into a positive pin. Let's double check. Let's see that. Let's make sure that our plus and minus V are in the right spot. So we have a capacitor going to ground on either end of this. Those two ends are going to be positive or negative depending on what orientation. What are we looking at? This is Dave's synthesizer. This is another step in the process of getting to know the circuit. I want to be able to walk through the whole circuit piece by piece, removing resistors to disconnect different elements of this thing as we slowly move through the functionality of it. In order to do that, I need an actual schematic that represents exactly what's on this board. And so I have taken the time to do all of the tracing of the images on this thing, so we know where that copper is connected based on the GIMP image. Hate that we have to call it GIMP, but now we're putting all of these devices onto a piece of paper. We're actually getting the schematic elements down. Put a lot of work into this, you know. I want to at least have the ability to make one for myself when this is all said and done. Said and done. There's a question of fun. Okay, so if I don't look at the ICs and I don't look at the top and the bottom traces, I can see that there is a slash in the side of the IC. Let's double check that with the actual device. Sometimes I've had to do this without actually having the device, and that makes it that much harder to check over what's going on. There's a question of fun. Let me get this stand out of the way. It's really messing with me. It is in the way, and we need our mobility when we look at this stuff. All right, so we are here, and we've got that 104, and we've got the slash mark in a TL072. And the printing is this direction. So pin 1 is down here on the left. Back into the left, back into the left. Pin 1 is on the lower left-hand side of that chip, if we turn it. So that's pin 1. Let me put the IC back in. We do have it correct. We are going into the positive input. So we're non-inverting. Here's the thing. You guys we don't have to be smart. Everybody thinks we're smart, but they're wrong. All we have to do is look up op-amp circuits, because it's a whole op-amp circus. There's the top 10 fundamental. This will help you out a lot. Articles like this, where they just list stuff off and they have the different designs that you can do with op-amps. Generally, I was expecting to see this as a non-inverting op-amp. It seems like we have something like, not quite like that. It's possible that it looks like this. And perhaps we're doing that in order to get it into the m303, what do you call it? The m303 voltage level. Make sure I put all the elements of this project out on the table so that we can see them. Put my flashlight back in my pocket. I'm just happy to see you. All right, so the reason we looked that up is so that we can make our circuit look like this. Although we're not going into a resistor initially. We're pretty much raw dogging the op-amp, and I don't really understand that very well. Our external signal's coming in on this line right here, and it just goes straight up into this thing. And there's a cap over there. What's going on with that? Oh, those are just ground. So I guess they didn't do a flood fill ground on the top layer here. Don't know why. That's a strange design choice. We're definitely going into that pin. See, if we flip this over, we would be going into... No, we'd be going into an output. So yeah, that doesn't make any sense. We're definitely going into the positive. That's strange. And then over here, it's unity gain. Those are connected together. What are we comparing it to? What the fuck? Okay, all right. I'll just put it in. I'll put it in. There's a 1M to ground. So let's go to our components, and we're going to go to components, so component managed, and then I'm going to do resistor. This is set up for 0603. Let's just put an 0805 in there. The package isn't as important since this is just a working document, but okay, we're going to need a resistor that goes to ground here. We're going to need to avoid some of the stuff that's coming off of this amp. So what I'll do is give it a little bit more space to breathe. And then I don't know, should we flip the op amp around? I guess I'll flip the op amp around. I'm not really sure that if it's in a positive or negative configuration, so I'm going to flip it around just for the sake of display and do the line like that. And let's copy our ground. Copy that floppy and get that all connected together. And then this loops around. I'll take it from the same spot just so it looks consistent and loop it around until it goes back in to our input. That is a strange circuit. I don't know what the hell's going on there. Op-amp and op-amp circuits, for that matter, are still confusing for me. I really need to look more into that. Yeah, they're a little bit counterintuitive, and I don't know why there's such a like a staple in these designs, you know? Basically, you can think of that feedback element as tamping down the feedback, because there's a huge amount of feedback within the op-amp, and it's comparing two voltages, but if you feed it back into itself, it inverts and cancels out. That's the only way that I'm able to refer to op-amps. Otherwise, they are literally just equation machines. They're just transfer functions. That's what they all boil down to in the end. It's like we're not using it as an integrator. We're not using it as a mixer. Maybe as a buffer? Converter current voltage. We're not trying to do that. Negative resistance? I don't think so. Peak detector. No, not quite. I've seen that used in a couple circuits, but the configuration of the op-amp is kind of confusing to me right now. Well, let's put more of the circuit down, and maybe with more of the elements of the circuit, it'll make more sense. I thought they would be using it as something like a summing amplifier or, you know, some similar non-inverting summing amplifier. But they've got unity gain and a 1M to ground. Value. 1M. Let's get the value down for this one too. 50K. That'll help me later in the design stage. We don't necessarily need to worry about it right now, but that's on the input jack, yeah. So what they have is they have a CV from the front panel. Oops, what was that left over? Hold on. A CV coming in, either from the pin header or from, you know, a plug-in thing. And then we're going into the positive end with a 1M pull down to ground on a unity gain amplifier. I don't know what that accomplishes though. Voltage follower. I use these with analog accelerometers. Why would you have a voltage maybe just as a buffer? You just don't want to directly connect to the rest of your circuit. You don't want to directly connect an external CV because that might screw up your electronics. So you put it through some kind of a buffer, and that would be a voltage following unity gain amplifier. Yeah, voltage follow equals buffer. It's a strange buffer, but all right. This way, if your whole circuit explodes when you plug in a CV, you can blame the CV, and you can blame whoever made your TL072. So over here on the design, so now we're at the output of that, which is kind of sloppily put down here. Get rid of the bottom layer and see if that looks a little bit clear. This is why we work in multiple layers, so I can enable and disable stuff. So I am to assume that this is coming from over here, and it just broke because I've been through a couple revisions of this. So we're going two directions with this. One of them goes back into the next op-amp. Or is that, no, that's not left over from the lower layer. Oh, no, wait, it jumps. Oh, that's not connected. Okay, never mind. So we're actually connecting to that via, we're not involved with this. We're over here. We're at the connection of those two. And that's coming out of here and going down to 1203. Can you even count resistor? You know 0 doesn't go there. It goes before 1. It's 0, 1, 2, 3. 120, 120K. So let's pop a 120K down here. I could just copy this. With the designation above. And let's tighten this up a little bit and do this. I want to spread out. I don't want to totally minimize all of this, but yeah. There we go. We are, after all, we are after documentation and not, okay, so typically with What we're doing right now is documenting where everything goes. So we want to get stuff to be in logical structures so that it can communicate what their functionality is. We're going to get into stuff we don't really understand, and we're going to have to look up a lot of things so that we can see how other people represent these. And sometimes you'll have to look up multiple different representations of these types of circuits and see how they're laid out so that we can communicate those layouts to other engineers. That's the whole point, is that we're putting it into a structure that says, hey, this is that circuit that you worked on in a math class once. And you go, oh, yeah, that's right. That's what that is. The other way that we do schematics here is with no values. We don't put any values in, and we crush everything into its minimalistic form. And the point of doing that in this CAD program is that we are programming the CAD program on what junctions are connected where. The program doesn't care how you've laid out the circuit. All it cares about is this goes to here, and it goes to this and this and this. And I'm going to draw a wire straight to it so that the user can draw a physical trace down. That's how we normally do stuff with these things. I usually don't author schematics in Fusion 360. If I'm going to make a schematic, I'll do it in MS Paint. I don't care. But specifically with this project, because I might want to do a design from this, we're doing two birds with one stone. I'm making a communication schematic that is going to basically spell out how this thing works, that can also function as a design document. So a little bit of one, a little bit of the other. We get to have both here in electrical engineering. Our hieroglyphics, blah, 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 our hieroglyphics are actually computer programming. We're all the way up here at the top of the diagram. We've got a nice little buffer going on here. I'm going to highlight everybody. I want to pack it in just to, okay. Why do you do this? Why do you do this? Control Z. All right, let's just take this and move it back till it's here. As we go, if we neaten up, we'll then have space to do all the other stuff that we want to do. I think I'll leave this like that. Okay, so we'll just take a net and we'll put that right there. So we go into, oh, the value didn't stick. Value, 120K. Did I? That was weird. Yeah, I wonder why the value, oh, because I Control Z'd it, that's why. Okay. It's a buffer to deal with impedance. How does that, is that what the 1M, I guess, is there, just to make sure that it's got something to bleed out to ground? And then impedance, that's interesting. So if I look up, I kind of want to just know op-amp impedance buffer. Shut up, AI. What wrong answer is it giving me? That might be right, but the ultimate electronics book. A voltage buffer, also known as a voltage follower or a unity gain amplifier. I've used all three of those terms. Well, maybe not. Yeah, no, I've used all those terms. That's what I've been saying this whole time. Hold on, let me read about it. I don't need you to tell me. I got a book right here. Amplifier with a gain of 1. Yeah, well, that's a unity gain. Yeah, thank you. It's one of the simplest possible op-amp circuits close to feedback. Stage input impedance from loading the prior stage's output impedance, which causes undesirable loss of signal transfer. All right, well, it just makes sure that whatever's coming in is repeated on the output. I've not seen this circuit a lot. Maybe because it's so simple and stupid. Also because you can use your initial amplification stage as your buffer. Output is connected back to the inverting minus. Common with analog signals, yeah. I don't know why you would dedicate an entire op-amp to this when you can also use this in order to get your input signal down to a level. That's what a mutable instrument does this. Mutable instruments does this. But instead they have like a capacitor protector for static electricity, and then they bring it into like a low voltage op-amp that can take the high voltage input if it happens to be, but then that'll get it down to microcontroller level. It just, you don't waste an entire op-amp on a buffer. But to each their own. This is how Acid Labs decided to do it. They have 1M to bleed off that line, and then they also have the buffer here with the op-amp in order to kind of turn the voltage signal into your internal voltage signal and keep you from harming things or getting harmed. So if this CV comes in too hot, this thing will just max out and not bleed a high voltage signal into the rest of everything. Well, yeah, let's see what happens here. I thought they might use the second op amp in order to mess with it, but they have a lot of inputs and outputs, so let's just see where the signal's going. Let us see. So on the outset of this, we go into the 4016 and the quad op amp. Or is that the... yeah, this is the quad op amp because it's got power on ground in the middle. Actually, let's just see. Boop. So yeah, we are going into another op amp, and we've got a couple different destinations here. Quad op amp and one of these switch thingies, which are a little bit weird to me. Switch outputs at those two, which go to ground. 2 capacitors to ground? What the f... I'm still dubious about this being a 4016, even though we know it's in the design. Well, let's do the op amp first, just because it grounds us in things we know. So we're going into another positive input to an op amp. And our negative is coming from... That's the underside of the board. I messed up my top and bottom around here. So I kind of messed up some of the signals. Okay, so that's not involved with our circuit. And I should probably translate this into blue. That goes over to slide in. Slide in goes all the way over here. We're not going to deal with slide in until we get to this part of the circuit. Okay. So this is coming into lay op amp, and this is not on the top layer. This is on the top layer. This is not on the top layer. I could, I guess, correct that. Just draw over it. Even though this is stuck on the top layer, I'm going to do this to prevent confusion. Wait, that doesn't go to slide input? What am I smoking? Okay. That'll keep me from getting confused. Usually op amps are stable with the gain greater than or equal to 1, so they're configured at least unity gain and then followed by a voltage divider if you need a lower signal level. That's a strange thing to do. I don't, because you can just set it to, I guess, yeah, moving downwards in voltage is the tough one. So you divide it out. That's a strange one to do because the statistical averages of resistor values play into that. They do it so there's no voltage loss. I see. Okay, so confusion aside, let's get the bottom layer out of here. We come in through a 120K and then we go off in 2 directions, and one of the directions we go into gets us into another op amp where things get a little confusing. Oh, this one too. This is confusing too. Hold on, I gotta edit myself out of these mistakes. Mistake! Let's see. So we're coming down here, and I'm still on the top layer, but I'm gonna mark this as a bottom layer so that I don't get confused. Where does that one go? Oh, it goes all the way over here. There. No more confusion. I didn't think we'd have to get to this level with this thing yet. I was going to, try to eventually get to doing this Fusion 360 stuff, but we've been backed into a corner. This design has been absolutely obnoxious. For some reason, some part of it is not working properly, and so we need to go through it like on the level of on a cellular level. We need to go through all of the facets of this design, and so here we are. We're in the mines. We're reverse engineering things from nothing. And it's not that we're unfamiliar about doing this. It's just that this is a lot of work. And I've been asked questions about this part of the process. I avoid it like the plague. And people said, I would love to see you reverse engineering something, from that level, from the stuff that you like, similar to how you used to work. I would love to see you reverse engineering something that involved, that level of raw reverse engineering from the bottom up. So here it is. This is what it is. It's work. So we're going to continue to do the work. This is common in RF stuff for the voltage divider. If it's on an input, the ratio of your impedances between source and input creates a voltage divider. Oh, I see. I see. Impedance mismatching causes signal reflection. I don't think at these frequencies you're going to see signal reflection. All that weird wibbly wobbly RF stuff, you need to get up into frequency in order to experience it. Maybe it does. I could easily be wrong about many things. I'm wrong about so many things. Okay, so what frequency? How the fuck should I know? we're dealing with audio frequencies here. We're in like the hertz to hundreds of hertz to kilohertz. Barely. Oh, I have a notification on Twitch. Hold on, what's going on over there? The input from this input pin is the CV input, control voltage input. So it's going to be a plus minus 10 volt signal on the order of like a low frequency oscillator to not quite audio. It's going to be simulating, well, the notes of a song. Those would be the different voltage levels that you can get in. So in a sense, it would be like the speed of a human playing a piano. You can think about it that way. Very low speed. We're not going to deal with like signal reflections and stuff like that in there. Okay, or resonances and things. So we're only going to this pin. The other part of it was just confusion from other traces that are going under. The minus input and the output are connected. Where do they go on the top layer? They go diagonally upwards and into another switch. What is up with these switches? Okay, so let's put this TL074 down. So let's grab a TL074 for my components. Sorry, chips. Chips components. I don't know why I split them up like that. It just makes it easier to find what you're looking for when you're me. And this one actually isn't the A. Well, we're not going to bother. I'm not going to bother with A, B, C, and D. If I was looking to do a complete reverse engineer of this product, then I would do a complete reverse engineer of this product. We're going to keep the op amps in their chips, but I'm not going to bother which one is A, B, C, and D. I think that's a little bit too much to worry about. Because when I go through and I mess with this thing, I have this document to refer to, and I'll know that it is an op amp that is within this one. The specific pin numbers are not a huge concern for me. The oscillation needs to very precisely follow the control voltage, otherwise it won't sound in tune, so a buffer in there is a must. Well, I mean, yeah, it's buffer, but I mean, you could have a CV coming into a VCO that is going through I mean, Jesus Christ. I can just open up a mutable schematic and show a totally different... let's do just any old. We can look at like I don't know, rings, whatever. The design of these going into a microcontroller is typically the same, but it's like having a buffer in there. You still have a buffer if you're taking your input signals and you're putting it into just like a you know, whatever. MCV 6002, we're taking it down to 3 volts, so we need a third of 8 volts. So in this case, it's 1 to 2. It's a tenth, or a fifth of the voltage. You're doing it this way, you still have a buffer. I don't know. Op amps are cheap. Not necessarily. You need real estate for op amps, and in a modular synthesizer, you don't have a lot of real estate. You've got only so much board space to deal with. All right, so anyway, we come in here and we're doing another buffer, which seems a little bit odd, but I guess we're going into a switch stage. The output here is also traveling into an adjustment. Okay, so we've got an adjustment over here. That brings us all the way over to here where we have some oscillating stuff going on. So let's get this other op amp in there. And this is another one that's at unity gain. And then we have some kind of a switch involved in that as well. Yikes. Okay, so TL074 going down on the board. TL074, doobie-doop. And we're just gonna punch these things in here. They don't need to be exactly. What I'm doing is I'm right-clicking twice and then center-clicking, and that flips this around and then mirrors it so that everything is in the right spot. With op amps, you can flip stuff. You can flip your plus and minus just as long as you keep the pins the same. Put this in here. So B, C, and D. So those are the 4. And then I'm going to invoke the power, which we'll get to later. So once more into here, but there's going to be a junction there for that switch element. So let's move it out a little bit. And then we do our unity feedback. I want to give it a little room there, so I'll just do this. Unity feedback. And then that moves to greener pastures. Meanwhile, we come down here. We have another element to this, and that involves yet another weird thing that I have to put into this design. So let's just put all these together and just keep them kind of over here, because we're going to have a bunch of elements coming into this. So we are now going to insert a weird chip. That would be this one. CD4016, it's 5 switches. Does that have 4 over there? There should be 6, rather. 6 analog operated switches. So we got our first one going in. I'll just put it right here. And then 2, 3, 4, 5, 6. And then these also have power. Wait, this is only showing 4. Ah, geez. I thought I corrected this. The 4016 has 6. That's a different device. 3046, 4016. How many are in the 4016? Hold on. Maybe I didn't correct this. We need to go in and edit the part if that's the case. .4016 is only 4 switching elements. Okay, good. Never mind. I did it right. I did it correctly. I did everything right. 4 switches. Switches get stitches. All right, so 4 switches. Oh, can I Control Z them back? No, they're dead forever. So bring these back. Switch A, B, C, D, and then invoke power. I don't know how to get that on another page. I'll have to figure that out at some point. These don't exactly sit properly. I'll just put it over there. There should be a name and value on that. Oh, well, whatever. We'll do all the decoupling later. Okay, so that goes into the switch here, and then I guess I need to make a little bit of room for whatever element is going to be switching this. I don't know what's going to be setting that off. It's a strange design. I don't know why they would have that in there. We'll explore it. We'll take a look for it. And this maybe this will be better sitting above, because I like to avoid crossing lines in all of my stuff. We'll see if that's the case. Let me just move. Oh, wait. I didn't grab text. Grab everything. Let's move them all down just a little bit so I can do the switch thing above. Because the other side of that goes to... Actually, it should probably be below because it goes to 2 capacitors that go to ground. So, or on its side. But maybe we'll keep this thing upright for now. And I'll do like this. And then I need 2... And I'm just going to put them in as 0805s. So I need 2 components that are capacitors that aren't 6013 film. We'll do 0805s. And they are in parallel. I'll do them facing inwards. We'll double check that they're parallel. I think they are. I'll do a center. Move this over 1. And then pop a ground on that. Oh, I actually want to give these a little bit of breathing room. Do it like this. There we go. And then this too, breathing room. I don't like to have it connected so close in. Okay, that was weird. There. I only do three-way junctions too. That eliminates confusion. Not even sure how you get around using a Unity game setup to accomplish what they're probably trying to do, actually. I have no idea. Okay, back to the physical board. Let's double check. So 120K, one branch goes upwards, and we go up, and we're in this 3 out of 4 switch. And the output of that switch goes 2 ways. One of the ways is into two capacitors that are just kind of chilling over here. And those two, we don't know the value of those capacitors, but those 2 capacitors go to the bottom layer, which is a via that goes into a ground plane. So that is technically a ground. I just didn't mark it off as such. The other part of that goes to another switch. So on the top layer of the board, the connection on the other side of the one switch goes to the other side of the whatever. Okay, so we'll bring in another one of these. I'm not worrying about A, B, C, and D on this. It's a bit much to worry about. So I guess then I would rather have this be centered. How do I put an edge into one of these? I don't know how to do that. I'll just delete it and put it back. Just because that looks good. It looks symmetrical. There we go. And we can tighten that up a little bit. Bring this down. I need lasso selector. Boom selector. That, and then I can bring this one in. Just like this. Assuming that's all that connects these two at the moment. That's weird. That's a weird thing. This is getting strange. Whoops. Over here. Output of that switch. Holy shit, where is that going? That's the op amp we wrote in on. Wait a minute. The output of that goes to the other side of this switch. What the heck? Something weird's going on. So I'll take this, bring it into the center, and do one of these. This is not normal. These are not healthy people making these circuits. They need help. What other destinations do we have? Or is this even accurate? Did I mess this up? Yeah, this should be accurate. Come in here, 120, go into this pin. That's the only destination for that one. Inside of this switch, outside of this switch goes to this pin with the 2 caps. This one goes across and down and into this input, and then the output from that switch goes into the output of the op amp, which may or may not have another destination in mind as well. It does. It in fact goes up and over to there. And these are connected across there, but then they also go, why wouldn't it just, it does go up there. Weird. Why wouldn't you just go straight in? That's weird. That's weird. So then we're also going all the way over to this part of the circuit, which has a frequency adjust potentiometer. I think. This is a confusing part. Poor blonde dog. Doing some electronics tinkering with some silly stuff. I had one of those dollar store solar lights. I was seeing why it wasn't working. Interesting design. Talk about minimal components. Cost is everything with stuff like that. Yeah, they're gonna tamp down the number of components until it's unrecognizable. So the question is, are we going into any of these adjustment devices How do I know? I mean, I haven't desoldered these two, and I don't really know quite where all the pins are going on them. But it seems like we're getting to some of the meat of this thing, some of the frequency adjustment things. We've got 2 pins going into these pots, and then those go into other elements of the circuit, but it looks like it comes back all the way over to the op amps that we're dealing with. Oh, and there's another tune adjustment. That feeds into there. That's on the bottom of the board. Unfortunately, there's an error where I forgot to switch it, and that goes to ground. Wait a minute. Unless that's on the bottom side of the board. Yeah, my messing up on the top and bottom here really messed with my ability to reverse engineer it. Hold on, let me get the pen out and do a little correction on that. I'll just know that the dark purple is my mistakes. Do do do. Do do do. That's... These are too confusing for me to allow to live. And doing this will just kind of clear the air so I know that certain things aren't connected. All right, I think that's most of them. There's, I think, a couple up here. No, it looks like they're all represented. Okay, cool. All right, so we have looked at this, and we have our signal coming into the 120K, goes over here, switch, switch, blah, 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 and then we're coming out here. No, that's the second switch to the third. And that one comes out here on the diagonal to where this is. This one also goes out to an adjustment, and that would be that one there. We need to figure out where that's headed. So let us get a signal from these 2 pins and ohm out where it goes over here. And for that, we need the multimeter. The multimeter. The multimeter. Well, and we use it in ohms mode. We do not use the beeper. The beeper can lie to you. The beeper is there to test diodes, and it's not meant to test traces. If you want to know where a trace is going, you get more info from ohms mode. You can tell if you're going through a certain resistor, or you can tell if you are, something else is going on with your chip. The beep mode will lie to you is the lesson here. So beep mode squad, we go from the top left. Oh, you're not seeing what I'm seeing. Little do you know. Just in case, let me just do this. Just ohm this. Why are you beeping at me? You're not supposed to be beeping. Oh, you're in beep mode. I don't want you in beep mode. I want you in ohms mode. So yeah, you can see here. People get mad at me too. If you can't see the meter, fine, use beep mode. But I'm telling you, it's not a good mode to use. It's kind of a bad mode to use. It'll lie to you about stuff. And people get real nettled when I tell them that. But you know I'm right. There are not any really good cromulent arguments for using beep mode. Beep mode is meant to be a diode testing mode. So we've got our connection here that goes all the way out to the adjustment. And then we've got our confusing trace layout over here. We can probe in and see where this is going. Well, okay, I immediately got it. It goes to the wiper. It goes 1.1 ohm, unless the wiper's all the way on one side. We don't know that. So where are the contacts for these fucking things? There they are. Let's just check what the value of the resistor here is. Huh? 1.2. 1.1? What? Huh? Why would the whole thing be giving me... Maybe we're all the way to one side on the adjustment here. This adjustment is invalid because I replaced some of the components, so... It's all right, let me just give this a twist. Isn't the difference between beep mode has something to do with continuity? 10 diode mode? The beep mode is a diode mode. It's testing to see the forward voltage of a diode. And if it sees an NC, then it doesn't respond. It sends out a beep. Or no, if it sees a connection of a certain amount of volts, it'll let out a beep. I'll try to test you for continuity, whether you're in continuity. 102, 103. So this would be 100 ohms. The other one's 1K. So yeah, this is probably in a variable resistor kind of mode. That's still 1.3, and this should be a couple K. I'm still getting ohms across this thing. What the fuck? How many? These are like 25 turns, right? Going in the wrong direction, maybe? I have to feel for an indecipherable click. There's a little click when these things get to the end of their travel. It's basically a worm gear and a potentiometer that turns. And the worm gear has a particular ratio to that turning. Keep going until I feel a click. Or I hear one. Not getting a click. I don't hear it. Try the other direction. All right, let's test that. Okay, so almost a kilo ohm. Okay, cool. And then this will be low. Yeah, that's 0.4 ohms. So it's basically, this is connected to here, and then this is our input. And then this, right here, should go all the way back to these two. 2K, what? 30K, what, huh? What the fuck? Wait a minute. Oh no, is it? Yeah, no, it's these two. Or is it these two? It's these two, it's these two. Yeah, there we go, 0.7. Okay, cool, so now we know. So for my notes, oops, that's the wrong computer screen. No, everything's, what? Oh, hello. Okay, there we go. Let's do pen, and let's do red pen, and we'll do red pen for top layer. Even though I don't really know that it's top layer, it's gonna go here, and then this one is gonna go here. So it's basically like that. I guess I don't really know that there's a trace there. I should probably not mark that down, but whatever. That'll just be a confusing line. All right, so that means that in the schematic, I'm going to have a 100 ohm resistor to ground off of this pin. What? That don't make no sense. All right, so, well, it'll make sense when more of the circuit comes into play. I'm actually going to do it over here, just as another thing that this travels to. Because, yeah, that would make a little bit more sense if it's out here. And let's see, if I do I have an adjustment pot? I don't think I do. I mean, mechanical, but then let's just see if I've got any trim pot. What does that have? That doesn't have a 3D model. Okay, well, I'll put in a square trim pot, and we just won't have a 3D model for it. I'll put in like one of the 5mm ones, I guess. These are all hateful, these little surface mount trim pots. But the reason that these exist is to adjust the frequency and the spread of the control voltages that come in. Yeah, the other ones that I have are Alps, and those aren't really appropriate for this. Let's just put that in, and we'll put, so it's, what's the first connection? It comes into the wiper, I believe. No, actually, it comes into the one side thing. We don't know which one's which, actually. So then these would be connected and go to the rest of the circuit. So maybe it needs to be like this. And then the outer element is the one that loops back. So I'll do it like this. And there's the rest of our circuit there. And let's just make sure it plays nice with everybody else. This is a pretty wide element. I don't think there's much I can do about that. And I don't know where the controls are coming from for these two. So I don't know if this is going to work out in terms of design. And I also don't know whether to put it like horizontally or vertically or what. So a little confusing. What does that do for you? I don't understand what that does for you. Very strange. We'll have to get to the bottom of that later and see if we can find structures that look kind of like that. I usually give one block of wiggle room to the next piece of functionality. So like here I've got one block there. Okay, let's see. We're getting deeper and deeper into the circuit, and it's like we're not using up some of the elements that are over here. Like we've still got this whole other op amp that's probably responsible for another CV coming in, and then we've got 3 op amps that are not being used, and yet this is about to go into the next chip. This is going to get really weird. Things are going to get weird. Oh, the value of this thing. Value is 100 ohms, right? It's 102 actually, so it's 1K. 102 and 103. The 103 is 10K, so yeah, this is the 1K. And then I'm gonna put, I guess this would, one of them's gonna be spread and the other one's gonna be frequency. And I don't know exactly how those are gonna be arranged. We can look up transistor VCO schematic. The VCO that uses a supermatch transistor. I just want a schematic of one. And there it is. So one of them is, oh, this doesn't tell you which one is which. This one looks like CM3340. You've got all your balanced inputs going into an op amp, which are fine, coarse, and then CV adjustments all going into the same thing. And then there's your supermatched pair creating the oscillating element. I guess I should just call it trim. What does the 303 call this? If we can find where we are on the 303, we're in pretty unfamiliar territory because we've got the Acid Labs design coming in with a CV input that this didn't have. So somewhere this is going to start resembling the actual tuning circuit. But for right now, I mean, of the tunes, the trims that we have, TM4, I thought there were a couple others in here that we don't have on this board. We have 2 tuning elements. That's slide control. There's another one in here, I think. One there. Oh, these are right here, TM4 and TM5. Tune at width. TM4, they don't give a value. 4.7 for one, and the other one's 4K. 4K trim pot, what is that? A weird value. That one goes up to 5 volts, and the other one loops back on itself. So TM5, they don't tell you what it, oh, width, they tell you what it is. Yeah, they do. So that one might be width. We'll guess, and we'll call this one width. Since it's a 1K trim pot, but the design of it, I don't know, maybe that means that it is. So let's document, and we're going on the info layer, sorry, and we'll call that width. I'll just try to keep that together. Does that make sense for a width? For a CV coming in to get buffered, and then whatever the hell's going on here to get buffered and turned into some kind of an oscillator, and then somehow limiting it over here would affect the width. I'm not sure. I'm not sure what the end layout's going to be. We're just going to keep moving forward. Just one foot in front of the other. Why are people sending me messages? There's just a bunch of stuff going on. Oh, wow, because it's late. How's it so late already? You know, you get into this stuff, and the world around you becomes a blur. So we're back to here, and we got our whiz width, but our whiz width exits, and there's another 470, and is that a 1? Yeah, so 4.7K that goes into other elements of the circuit. It seems to mix with other stuff. So this is our CV influence coming in here. How would that affect maybe the voltage range of what's allowed in as a CV? So 4.7K, and then I think it's then going into the actual oscillating element of the rest of everybody, the stuff everybody else has. So we're going to go to components. We're going to get a resistor, LED fuse diode, PQR, resonator, resistor, 0805. That's just a comfortable soldering size. 0603 is pretty good too. I mean, I could live with that. But I'm not totally worried about the size of the elements yet. I can always go through and change them too. Value, 4.7K. Since we don't have C's and R's labeled on any of these components, we can't get that sort of level on them. Oh, exploded. Oh yeah, just what did I miss? I missed a lot of things. Okay. So 4.71K. Maybe that's not all there is to this story. We're not sure yet. We keep moving through the circuit and marking down what everything does. Our other adjustment, this one over here, that's probably looping in and then coming through a 203, so 2K, no, 20K, and then that goes into a 1K to ground, sorry, 100 ohms to ground. Another one that goes over to another op amp. Jeez. Okay, let's circle back on some of the stuff that we were doing a minute ago. We've gotten one of the structures here with these two, and some of this other stuff has been noted down. I could mark this stuff as having been done, and I probably should mark our progress so far. So I'm going to go to my done layer, and I'm going to get my piss yellow marking here. That's over here, the done layer, and the piss yellow marker, and we're going to mark down what we've done so far. So we've got CV in. Let's get a slightly larger cursor on this. I really want it to be like a big X out of all of it. We can always turn the layer off if we need to see certain things. So we got this thing here. That's too big. And actually, we can take this layer and we can turn the opacity down. That'll help us out a little bit. Like 65% opacity. That doesn't help at all. That doesn't look right at all. We got the 1K here going to the ground. And then we got this here. And then we got this thing over to here. And that goes, where does that go? That goes down here to here. And it goes down this way to here. This thing is circuitous, isn't it? Hey, what's up, Syphilid 8? Syphilid 8 subscribed for 42 months. What's up, Mother? How's it going? We're doing work today. We got work to do today. We got to do work. Thank you, Syphilid 8, for the continued support of weird-ass content like this. It goes a long way, believe you me. That connection, we got this, which goes to, we got this switch, but we didn't get the full story yet. Here to here, we got this, these two, and we got this connection. That's done. And then this is all part of documenting what we're doing. This one down here, which goes to here. We got that. I haven't gotten any of the control signals for those switches yet. That's going to be this and this. Oh, they're both next to each other. They're right here. They both go over to our Schottky diode stuff. Ay, ay, ay. Okay, so we'll wait on that one. We'll wait on that one. And then over here, we get signal. Main screen turn on. I'm seeing things happening. Syphilid 8 is gifted 5 tier 1 subs. Dude. Whoa, you don't have to do that. Hey. Syphilid 8, thank you so much. Syphilid 8 gifted subs that are going to Kuro Data, Venity, Mr. Soffit, Pyromad, I remember that name from somewhere, and Paloozer. Keep making weird shit. I promise you as much. We unfortunately, because of all of the work that we've been putting into Dave's synthesizer, this circuit has been doing nothing but piss me off. And I'm so mad that I'm going through the very, very low level reverse engineering on this thing and trying to make sure that we get every element of this thing documented so that I can come through piece by piece and mark down what everything is doing and check on it and make sure that everything's functioning properly. So it's kind of annoying, but it'll help us in the long run. This is going to take a significant amount of work, though. And so this is where we are right now. We got this whole signal. That doesn't go to ground, does it? No, it does a bunch of stuff. And it goes to a bunch of locations, too. Like VCO mod. So this is where they're doing that mixing signal. Like I pulled up before, you saw that there were multiple different resistors going into this thing. Syphilid 8, thank you so much for the 5 gifted subs. I hope I've given you enough fanfare for that, because I really do appreciate you guys going out of your way and gifting stuff. What did I look up before? I looked up, yeah, Supermatch Transistor VCO schematic. And what we got is starting to look a little bit more familiar. We have an element here where we are mixing a bunch of different types of signals. So you have a fine and a coarse setup for adjusting frequency, and that's what this thing has in the first place. But all these resistors coming into a similar line and mixing together in order to bias something. That's sort of what we're going to start to see out of this. Hoop, hoop, hoop. Okay. Dear God. So far, the elements of what we've reverse engineered have been pretty spread out amongst all the components on the board. We've got a lot of stuff that's involved. I mean, we're going to be getting into the Schottky diodes next. But as we go, we can mark down the different elements that we put together, and everything will start to, hopefully, start to look like an actual circuit here. And since I didn't give myself a very large page size, we might spill out into the non-space in this document, and I might need to split it out at a later date into multiple pages. I guess maybe the frame is there just so we don't get the existential dread of having infinite space to work in. So we've gone to this 4.7K, and it looks like this 4.7K is part of a different circuit element. Now there are other things that we haven't resolved yet, which is like, for instance, how these two little switches are activating. What is setting these off? And it turns out it's the Schottky diode, whatever, not Schottky, the Schmidt trigger array, the hex inverting Schmidt trigger array. Huh. What is that supposed to do? You could just dump a capacitor on either end of this op amp, this unity gain op amp. So you can either bleed or boil. And that's supposed to be your control voltage input from external. So your notes are coming in, and you can at certain points. Huh? I don't know. That's strange. Well, anyway, let's get more of the circuit, because that's not incredibly clear what's going on, and we should probably get a little bit more definition of this as we go into it. We barely touched the surface, so we got to continue on. So from that 4.7K, we have a juncture that has a lot of stuff on it, and it looks like one thing has been cut off from it. That's a little weird. But that's going to start involving our transistor array, our super matched 5 transistor, whatever it is, the 3046M chip, which is it's an RF chip, but it's being used for analog electronics here. I mean, RF boils down to analog electronics. An RF chip because you need like more matched transistors if you're doing raw RF stuff. It happens to do a good job replacing the supermatched transistor pair of this type of circuit, and so Acid Labs scratched the markings off of theirs. Now you can see the markings on this one because we replaced it, but Acid Labs tried to hide the identity of this chip from us, and we took that personally. So to this juncture of a bunch of different stuff, we're going to add these resistors, and then we'll figure out where they go one by one. So let's start with our buddy over here that has a frequency adjustment on it. So 203, 3 zeros after the 2, so that's a 2K, 20K, there, 20K. Are there any other branches that we've neglected? I think we've gotten most of the branches of this stuff. Is there anything coming off of these switches? No. And this one? We got everything on that one. Okay, so we've got all of our locations on the sort of the analog switches. It's funny that they use all of them. What are they doing with all of these? Like, this is coming from some weird circuitry up here. I wonder if they use it in order to turn on different elements of the circuit, like shield it until it turns on. All right, so I do want to look at where these are getting their control from, but first I think we should branch out over here and get a little further in. So I'm going to need the 5 transistors from this circuit. Now I had trouble because these two elements elsewhere in the design are being used differently, and so I wanted to have two different transistors that were connected to each other on a pin, but I couldn't do that. Apparently you can't do that. If you have more pins than you have pads, not more pads than pins, it's more pins than pads, it won't let you associate it with a package. Instead, you have to have more pads than pins, and then you can double up the pins that connect to a pad. I don't know why they don't allow the former. I guess it's to eliminate confusion, but when you have shared pins on transistors that you're going to put in different locations, it would be nice if Fusion allowed you to move in the other direction. You know, pull up a pop-up that says, hey, there's something, you tell the computer, hey, I know what I'm doing, click OK. But instead, they don't let you do it. Very confusing. Let's get our 5 transistors down. Transistors. So I'll drop one here, and then we'll put the other 5 up in a holding area. And so for that, I need chips. Bonk. Yes, there's a heavy confusion element to it. It is one of the cons of Fusion. Why is this back up here? That shouldn't be in there. What was this thing called? This is the CD4016 CA3046. And I want the SO8 package, and we're not using that one. that one, that one, that one. Those are all of them. And there's no power pin on this to invoke. These I do want to keep straight because they're special ones in there. It's not just, you know, for the same thing. So let's take a look at which one we're using here. I think the 5 have different properties. I don't think... Are the 5 super matched? The 5 might be super matched. I'm not sure. So in that vein, the one that we're using is... Oh god, I don't know which one. It's the one on pins... What the hell are those pins? Pin 8. Pin 9. The one that's on pin 9. Go. That's our buddy. So where are these connected to? Oh, okay. Image menu. Where are these connected to? The base. Huh. They're all connected to the base. Interesting. The tracks, the base. Like so. Wrong layer. I always do that. We go to design and then we put down the nets. And that puts us on the right layer. And then we've got a couple more resistors on this thing. So let me place a resistor. Chips. Components. Resistor. 0805. How many resistors do we have? 1, 2, 3, 4. One goes to ground. So we have 3 more inputs to this. Doot, 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 and then we got a ground. That. Like that. The one going to ground is 1 0 0 0 0 0 0. Double check that it goes to ground. It does go to ground. You can see that there's flood fill in the area. 1 0 0 with 0 0 zeroing to 0. So it's 100 ohms. That's a very low resistor to ground. 1 hundo. Yep. Guess it doesn't put the ohm symbol on there for me. Why can't I grab the value? Why can't I grab anything? Escape, escape, escape. There we go. $100 ohms. And then we need a ground. Ground, ground. Copy. Place that down there. This will probably look more like a transistor circuit, so maybe this needs to go here. And then the elements that are mixed will just come in on that. Like so. I mean, that, yeah, maybe that'll do it a little bit better. Because there's other big structures that I need to associate with the rest of these. We'll need to figure out what they are. So let's just see what these are. Let me hook them up first. Bring this up and over like that. I don't know if they'll go above or below. Sometimes it exits you out of the tool. Sometimes it doesn't. I don't understand. I guess I was hitting escape too. And that's what would pop me out of the tool. I'm still getting my flow with Fusion 360. You know, we used to use this CAD program at my old job that would lay stuff out like this, except you would be using logical English-speaking keyboard shortcuts in order to do everything. So grab component, you'd hit GC. And so while you're working on this, you're thinking about it. You're like, grab component, make box, MB. Like, it was a strange one. It was made by one guy in Florida, made this software. And it's like, dude, how cool would that be to be the one guy who made this schematic software that an entire, like, contracting agency used in its schematics. And the only reason that they used it is because you could import an image. Well, I can do that in Fusion. I can import an image into here. Actually, I don't know if I can do it to this, but I can do it in the other like in the physical design stuff, I can import an image and then work on top of an image. But this doesn't allow you to do that. All right, 9, 10, and 11, we need to figure out what the values of those are. So one of them is going to be 20K, 2202. So that's 22000. So 22K, 22K, and then 100K. 22K, 20K, you value 22K, value 20K, hope. Value 100K. Cool. And I can keep track of those. Now, if I weren't doing this for you guys right now, first of all, things would be moving a lot faster because I could have all of my data on the 3 screens that I'm using. It really helps a lot to have CAD, your working document that you're copying, and like something distracting all on one computer. This is where 3 screens, this is one of the few places where 3 screens makes the most amount of sense. Now, I've gone down to 2 screens on my regular setup, and so that doesn't allow me to have the distraction element up at the same time as everything else. But I need something to distract me when I'm working on stuff like this. You're on my 3rd distracting screen at the moment. See, yeah, there's the reference screen, the work screen, and then the distraction screen. I don't have the distraction screen on my other computer because I found 2 monitors was enough for my regular working computer when I was doing stuff. But when you're doing stuff like this, specifically reverse engineering things, you can see we're jumping around programs a lot. It helps a lot if you just have them open. So this is where you justify the 3 screen setup. Okay, so 2220, let's trace back 20K. We're gonna follow 20K back to from where it belongs. It's weird, there's this other element here that is not incorporated into the rest of the design, and I don't know what to do with that. I don't know if I should put a question mark resistor on there. Maybe we will. Maybe I'll put another resistor on here. And just make it an infinite ohm. Copy this one, put it down here. Value. NA. Because I'm curious about the parts of this that haven't been installed. But yeah, we're mixing inputs that are supposedly coming from elements that are supposed to influence the frequency of the rest of the design. We have some kind of a weird switching thing going on right here, where it's switching capacitors to either end. Or it can just flow straight through without, but this is unity gain. Non-inverting? Is that inverting? No, non-inverting unity gain. It's buffering. Voltage following. What happens when you add signal in there with a strange stuff? Strange things are afoot at the Circle K. Can you make a part as no place to indicate its absence? I think an infinite ohm or a no not applicable ohm is better because the footprint, because I'm not dealing with simulation, right? I'm not simulating this. I have a footprint here for a resistor. So to represent that, I put in a resistor. I throw the bird. Did I do my 100 ohm to ground? Oh yeah, it's over here. Okay. Yeah, we'll get back to the NA, but I'll just throw it down there. We're probably gonna bust out into like no man's land over here, just because, and that'll get organized later. Right now, I'm concerned with just getting everything down. So actually what I'm gonna do is I'm gonna grab this and bring it up a little bit since we're working downwards. I'll fix slide in. We'll just bring it to the top of the page and we'll just spill out. So R9 is our 22K. We're gonna go towards the adjustment and see if that can pack in as a nice little succinct little circuit. Oh, 1203, 1.2K. Sorry, 120K. Where's that one? Did I put that in? I think I messed up. I said 2220. I messed up. Hold on. There's 22. 22. I thought okay, so instead of 20, I actually have 1.2. Or sorry, 120. Instead of 20, value 120. Okay, so that's the one we're going to work on first. So from this 120K, what are we doing? 120 goes to a frequency adjustment pot, or so we think, and then goes to this other tab right here. And that one goes back to what looks like the power pin. I think that's positive. No, it goes to tune. Our front panel tune, which goes goddamn everywhere else. Holy shit, where does this thing go? It goes everywhere. Wait, it goes to the power of tune. By the power of tuning. Ah. Negative V. Okay, so this is negative voltage, right? We're coming right out from the negative V pin here, where it's supplied from the modular synth rack synth. Comes down here. We're not turning left. Follow the road. Now we turn left. And we'll come down here and make a couple turns. We're not getting off at the header. We come down over here where we've got another capacitor to ground, another decoupling going on here. I think that's for this op amp. And we come back over here. And we go up and around to where we get yet another decoupler. And then we go into the negative supply of the op amp. Okay, that makes more sense. So the negative supply of the op amp. We're coming up and around here. And we casually just stroll in. Just don't make a big deal. It's not a scene. And we come down and around. And we feed our way into this potentiometer. So the question is, what the hell? I think this one goes between positive and negative. Let's just check. It might just go to negative. It might just be that negative. So if I test from here to here, hey, you guys can't see it. One point is usually, well, let's just check to see if I haven't adjusted it all the way to one side. So 4.6K. Okay, good. So I haven't adjusted it all the way. So from this 4.6K, I go all the way to my negative input here, and I get half an ohm. There we go. Okay, cool. So now we know that this just goes to a pot that goes to minus V. So in order to get minus V, I used the schematic symbols. So this would be the 120K, and I could probably clean it up and put it a little bit higher up. Where's the other adjustment? It's right there, so I might as well put it up there. So let's just delete this, delete this, delete this. I'll just click on it and hit delete. Bring it up here. I'll just put it alongside. Well, we can, oh yeah, no, that goes here. So I can put it alongside, and then I can copy this one. And now we'll probably move it down a little bit. There's no room for it to breathe. I need a little bit more breathing room. So we're going to take this mess. I can bring this in one, and that'll clean it up a little bit. Just like that. Now I have room to breathe. Okay, and then the one that was connected to itself was the one that goes off to the resistor. So it's the same sort of look as this one. I keep hitting escape for some reason, like that. And then this goes down, and I will give it a negative V, and I can get that from my schematic library. So components, schematic, and then I used VNeg. I had to make a new one, a new symbol for this, which is a little confusing. Okay. That's a little ugly. I don't think I like that. Maybe we'll move this whole business down. Just so that it's got like separation here. So it's just visual. These are visual things that I'm doing. It's me being kind of a diva when it comes to building the electronics, the schematic layouts. And then this is it still 1K? This one is 103, so this one's 10K. So we'll go into value, 10K. Move R14 inwards a little bit. Put that there. I think 10K is okay being at the bottom there. I do like them to be in kind of a block, but I think it's okay where it is. Just got to be consistent. Okay, now, we called that one width, so this one would be freak. Document layer, text, make sure we're on the right layer. We have very little working space because I'm in squish mode in order to properly communicate this stuff to you. I don't think it does circuit analysis. So there are spice models in here. You can do analysis in Fusion. Nice circuits are important. Are you really an engineer if your circuits are ugly? Some would argue, more than you'd think would argue, that you don't need everything to look totally perfect because it's just a working document. Don't let me make you lose your train of thought. It's okay. Attention right now are well, no, it's okay. Yeah, no, it's I mean, I'm trying to build a document that we can work from, so I guess I'm going to be a little bit of a diva in terms of how clean the layout is and everything. This does have spice models in it, but ever since college, a million years ago, I don't trust spice. I don't think it works at all. It's probably a lot better than it used to be. It's probably a lot better than it used to be, but like, oh my God, getting a spice model to actually run is torture. It's torture against an engineer. We were pretty convinced that LT Spice was a programmer's practical joke against electrical engineers. Yeah, I can't use, I just can't. I can't do it. Mm-hmm. Yeah, that's the thing is, for me, I have the luxury of time. I get to work on this stuff for as long as I want to. You're not going to get that, right? I used to not have the luxury of time. I used to have to get circuits out, done in a certain amount of time. So doing any of the stuff that we're doing here, like with the visually confirming it by having the pictures at the top and the bottom, this would be something that I have to do in desperation. And it would take me like a week or two to do the circuit. Now this is above the complexity level of a lot of things that I've seen, especially in IEDs. Now there were a lot, because again, these guys were scrapping things together from dumpsters. So we saw a lot of analog circuitry. We saw a lot of very complicated analog circuitry. We also saw a lot of very simple things. So when a real complicated device came in, it could be your pet project that you would work on in the background for like a month or two. But things had to get done eventually. So you have to kind of curtail how many of these diva things you're going to do. A ton of random, like, exotic pieces. Oh, what are we talking about? The components? Oh, for spice. Yeah. They're not as simple and normal components. I haven't used spiced in decades. Yeah. I haven't used it in decades. I don't know what it's all about these days. I don't know who's doing the spices or what. The Arrakis and shit. I don't know. So what we're seeing here is basically a summation of a bunch of different voltages, right? And part of that summation is the ability to adjust what frequency and what spread the frequencies coming in, or the control voltages coming in, can have. And so those are the two adjustments that we've gotten here with, I keep switching scenes, the two adjustments that we've gotten here with the width and the, and this one's going to be freak. So I need to do this, I need to go freak, and I need to go to the info layer, which we're on, and just label this one freak, like the freak that it is. So we get different voltages that come in here and they affect things differently. One of them will be a slide control that'll sort of affect how this thing can change from voltage to voltage as you get a CV in. If you put a lot of slide in there, then it's going to go to the different notes that it has to hit. Part of the cool parts about having a VCO is you get to affect these things. It's a dual layer circuit board, correct? Traces on the top and traces on the bottom. Yes, And if you're doing reverse engineering, and again, this is like part of what this stream is a bit more tutorializing of the reverse engineering. Now I have a goal, I have a thing that I actually need to reverse engineer. It's this greasy as shit board for Dave, which is a synthesizer module. So there's a lot of complexity, and there's sort of a goal here that I need to get to, so I need to get some work done. But the other part of this is actually explaining everything that I'm thinking to you guys as I go through it. One of the initial things that you will observe on a circuit board is whether or not it is a multi-layer circuit board. We know that we have 2 layers because we can observe the top and the bottom, and we can see how the layout is organized, and we can see that the vias are all in a particular way. You look at the board, you look at the spacing there, and you go, okay, well, that looks pretty good. I can see what the different copper layers are and how they're defined. I see a lot of vias here. I don't see any vias with a full circle around it, so I'm relatively confident that this is a 2-layer board. If I find, do I have a 4-layer board in reach? I often do not have a 4-layer board within my reach. Hold on. Here's a graphics card. This is a multi-layer board, and it is aggravating as hell to try to work with. But one of the things you'll notice is in multi-layer boards, you suddenly have vias with a complete circle around it. And what that's doing, that is a non-blind via, and actually probably a test point too. These are the ones that actually got solder mask over them. These vias are translating a trace from an internal layer to another internal layer. That is an indicator that you have a multi-layer board. Sometimes, though, you will have blind vias where this copper layer was allowed to etch completely over top of it. Those are a bitch to work with. They're absolutely impossible. Sometimes you can see evidence of them by just there being like a bump on this layer, but it's tough to know. Anywhere beyond 2 layers, 4 layers, 6 layers, 8 layers, you just don't know how many layers there are. In the case of this board, I believe it's probably a 4-layer board, although there are a lot of traces that need to go around a graphics card, so who knows. But it's tough. You can't really figure out how many layers your board is at a certain point. Luckily for us, this is very simple engineering. This company did not want to go all out and make a 4-layer PCB, especially not in 2014. 2014, I guess that technology was getting a little bit more available and cheap. But generally, if you're building something like this, you might as well just do 2 layers. It's much easier to check over your work and do fixes and stuff like that. It's very difficult to guess the number of layers by looking edge on. You might be able to. You might be able to make out the different layers by looking at the edge, but it's tough. It's real tough to do. Like, I've never really had luck doing that. Like, let's look at the graphics card. It seems like it should be the way to go, but like, how many layers do you see? Possible that it's 4 layers, but I don't really know what to base that on. They never taught me, no. I just look stuff up. You'd say it's 6. I mean, just given the level of technology of Radeon, this is a 2 or 3 generation old Radeon. So you have blind vias, a certain level of density of the electronics, and you have maybe an indicator by looking at the side, but not really. Not really. I would wager that this is a 4-layer board. I'm not seeing an incredible amount of density to the design that would garner that many layers. But then again, we do have an entire graphics processor on this thing. Where's that? It's right there. So perhaps to get some of these Johns out of there, you would need that many layers. They do a pretty good job, though, with what they have. Grown, yeah, they can electroplate the layer on after putting an insulative thing down. And that's usually how the vias are done too, is by electroplating. What did you do to that resistor? Shut up, I needed a specific resistor. This is a sacrificial board. I'm not plugging this thing in and getting it to work. I gave it to my buddy because we thought Star Citizen would have been a thing back when it was spaceships and not a full future life simulator. We thought it would be spaceships, and so I was like, you need a better graphics card, and I got this old one, take it. And so he ran this thing into the ground, probably by overvolting it, so it's dead. This is a dead circuit board, and so this became patient, just a cadaver for me to work on and get values from. Anyway, a GPU will have at least 10 to 14 layers. I don't know about that. I don't know if I can agree with you on that one. If you're right, I'm shocked. 10 to 14 layers seems like a bit much. Maybe on a modern GPU, but like, well, got a lot of insulating going on there. This is old. When is there a date on this anywhere? Model A84. For home office use. Made in USA. There might be a date code in some of that. Where's the year? Where does everybody puts a year on a circuit board? What are you people doing out here? I don't know. I don't know where the year code is. Oh well, whatever. We gotta get back to work. Back to work. Yeah, back before we invented USB. It's made in USA. Okay, so we're mixing voltages here in order to influence the note, the oscillator note. So over here, this is the beginnings of the oscillator. This is our input to the rest of the system, and we've got a 100 ohm resistor in here to, I guess, bleed it off to ground. I'm going to wager that one of these elements that we're going to look at next is doing some kind of like a slide from volt to, or a slide from note to note, so it doesn't instantly hit the note. It kind of curves its way up or down. You need 4 to 6 layers just to get the signals out. It's probably not in that range. It's probably in that range. I don't know, man. That seems like so many layers, though. That seems like way too many. Putting dates on circuit boards isn't a whole lot helpful. If you need an exact date, the circuit board could be made from... Yeah, but there would be something like a date code somewhere on the board. Like they have for tracking and tracing. And then a date on like the PCB is something that's more common than you would think. I mean, you would have that in order to be able to trace like where your designs are coming from, or when this made in China 2402. So this is from the 25th century. Let's see. Yeah, I bet one of these codes breaks down into a date. It's just not readily apparent. You see it a lot. You see a date quite a bit on these things. There's the 94V0, which is, of course, how this thing lights on fire. This company will purchase a large quantity of circuit boards for a product because of the price break. Well, yeah, it's a graphics card, so they're purchasing 1 billion of them. It might be used for several years. The product's like, yeah, but you still have a date code on the board. GeForce TI 4600 is a 2002 product. Oh my God, really? Oh, this is NVIDIA. Oh, Jesus Christ. Yeah, this is an old TI. Oh my God. So this is older. This isn't the Radeon. This is a different one. That's why. I thought this was the Radeon. The Radeon is the one I gave to my friend and he blew up. This one, just old. What an old graphics card. Anyway, that's trash. It's probably broken. Okay, so back to the circuit. We got our adjustments in there. So this is done. This is done. This is done. This is V minus. Mark it there. We know what it is. I'm not going to trace it all the way back. And then we're doing these. So I got this one to ground. I have computers that are older than that, but I don't use them very often. Man, that was the machine that I played Jedi Knight 2 on. I like that computer. My computers evolve over time. They don't really like, you know, they're not fixed. They evolve. So there's no point that I can say I liked this machine. It's more like I had this case for a while and I went through a few revisions. It was neat. Okay, so VCO, what's going on here? VCO in, okay, so this is the part that we made before. The part we made before, because we made this, and we can trace that out and around. Traveling across the circuit board. We'll get there eventually. All the way across the board. Over to our 22K. And we'll just do that. Bada bing. So let's grab this and bring her over. We can tuck that in right there. Look at that. Beautiful. It's like it was meant to be. And it was. Although that might be better represented going up above everybody else, but we'll just, oops, wait a sec, that was the wrong, I'm in the wrong palette. And we'll just grab, no, wrong thing. You clicked the wrong thing. What's your problem? Design. Put that there. Bada bing. Do you suck at spelling? No, I went to a private school that taught grammar very heavily, and yeah, I'm actually pretty good at that stuff because it's been beaten into me. Let's bring this up above. So this whole thing moves down, and our CV is coming in from above for the VCO. It's a curse, actually. It's actually a curse. Bring this down. Element by element, we are getting through this part of the circuit. It is a slog. It is not easy to do. But as we move, as we proceed, we get more of an idea of what this thing does. I'm going to put this like here. What about there? And then this can go, well, I don't want a four-way junction. I don't like those four-way junctions. But it better communicates. Well, then again, I don't want to bury that input into the rest of the thing. Can't even spell raisin? No, what? I always feel bad when I say I'm good at something because it's like, you always know people that do stuff a lot better than you do, and it's like, I do have trouble spelling sometimes, but not that often. And then you learn that it is a deep well, how low things can go in terms of being good or bad at spelling things. I do want to communicate that this is a bunch of different circuit elements that are coming together. It would be better if this one were sticking out like a sore thumb. Packing it in tightly is not necessary here, but I guess having it there is okay. It's just that if you glance at this, you could miss this connection right here. Oh, it was very frustrating for me to get into college and realize that none of my colleagues knew how to write a document. They were terrible at it. But engineering is just communication. This is just a form of communication that's very similar to a lot of other things. So like, oh, look at how much more compact that one is than this one. Wish I had a little unity in that. That would have been nice. Probably could have packed that in a little bit better. Oh well, it doesn't matter. These are the ones that are physical. These are the ones that are big knobs. You big knobs. Why did you do that? Stay right there. There we go. Schematics are communication. I'm writing a document that's going to tell somebody about how this thing works. So I want to be very clear in my communications. This is valid. It's just that it buries itself in this other circuit element. Spreading these out and having them like spaced out on different pages could even be considered here. You would just have this as like a mixing element, but I don't know. Let's keep working. We'll figure out what I decide about later on, you know, on laying this out. Because this could even be an element that I put down at the bottom of things. What bothers me about the college thing is cheating. There's a lot of that. Through-hole vias, 400, 600 ball VGA. That'd be like 20-ish rows of pins. With old technology, that'd probably mean 3 to 5. I don't know if I'm going with... I think 4 layers. I think it might be 4 layers. I wouldn't be surprised if it's more. I put in an order for a ton of pots, so I finally get to making modules soon. Get to making modules soon! Like, geez. You've been ordering parts for months. It's time. It's time to start building something, Speedy. You have more than enough stuff to actually start building things. There's no more excuses. No more excuses. Start building stuff. I want to see some results. Right, yeah, the special encoded numbers and stuff. I was hoping to see something that was a little bit more forwardly a date, but I think just going from the generation of card that it is, we can tell that it's 2002. And although they did have 6 and 8 layer processes in 2002, and it might make sense to do it in something like a graphics card, I don't really see any evidence of there being more than 4 layers. It just seems like, because we know there are vias that have circles around them, right? So we know it's more than 2 layers. 6 layers was a thick board in 2002, and this thing seems to get a lot done on this top layer. I don't see a lot of areas here where we have, like, there's one blind via right there. There's one internal via right there. That may be going to the bottom layer of the board. It may be going to ground, but like, I don't know. I think they're getting most of their goals accomplished via these tiny little traces getting in and out of this graphics card. I'm thinking 4 layers. Then again, the internal layers would be the travel layers. It might be 6 layers. You might be right. I might go with 6 layers on this one. There would be internal routing and then power. It's a long-ass GPU. Yeah, this is of the generation where they decided that it was too heavy. Remember when they decided that something would be too heavy for your case? And so they gave you a little bit of PCB, a little bit of FR4, in order to engage it with the standardized board holder at the front of the computer case? Remember when they did that? That was 2002. And then they lost their minds and made the coolers take up multiple different sockets and didn't give you any bolstering and decided that, oh, it's the motherboard's fault. They need to have a socket that is braced with metal around it in order to hold your graphics card up. And it's like, bro, it's in the standard. We have a shelf that can hold up your graphics card. Instead, people are making things out of Lego in order to hold their graphics cards up. Everybody lost their minds after 2002. I think that's really when the world ended. External sound cards are still awesome. I have an external sound card. Well, it's a DAC. They call it DACs now because they like to smell their own farts. Shit Audio, SCHIIT, makes a really good DAC that uses a vacuum tube, and it's only like $130. Or no, that's the headphone amp. You have to get the DAC separately, and I think that's $100. Still, like, the whole world of external audio, of it's not PCIe, but it is USB audio. There's some really cool stuff out there. I know, I hate to blow your mind today, but boom. Which scene am I going to? There we go. Shit is an amazing name. Yeah, because when you put together your stereo, like your audio stack, you're putting together a shit stack. I love that company so hard. It's like audio file level stuff for reasonable people that don't have tons of money to spend on audio stuff. What's blowing your mind? Not much. Just the fact that external audio cards exist still. 100 kilo ohm resistor. Where are we going? Where do you go? 100K? Where do you go? I will find you. Okay, so 100K, upsy dooble dabbies, and all the way back over here, under the chip. We sneak under the chip. We go down here. We're sneaking our way around. By the way, looking at all this stuff, this is so indicative of the designs that I do, where I'm like, where the hell is this going? How do I do this? Where do I put this? What is that? Okay, I need to go around here. You know, stuff like that. Tune. Tune goes to positive and negative voltage, and it just goes to the wiper of this thing. So the tune pot, what value is on that? Well, that's a nice, easy connection. That's nice and easy. Tuny is tuning. Tune of ohm. Gotta get the flashlight out. Maybe a little less flashlight. Why is there's just dog hair everywhere? Tune. There's just like a hair, just right on it, just hanging out, chilling, showing us all its gibbly bits. 50K. Tune is that's a beard hair. It's a beard hair. 50K. All right, so we're going directly to tune. Tune just goes to positive and negative. Nice and easy. All right, so here we put down a pot. So I'm just going to copy this one, place it, call it tune. What was this one? Oh, VCO. We'll put labels on that in a minute. That's going to need a little bit of room to operate. It's all coming together, chat. This is looking like an oscillator, an oscillator. And then we go to schematic. These are the foibles of Fusion. Fusion's just a little bit annoying. 12 volts. And then V negative is the one that I made for negative 12 volts. And that's what that adjustment is. It just moves that voltage level from positive to negative. So now I put the traces in, bada bing, bada bang, and bada bingus. Boom, headshot. Okay, so, and we got to put text on this, so document, and then a thing to put text in. This one is tune. I'll put it like that. And then this one is CV VCO mod. Yeah, maybe we should keep these readable. Just do them like that. Just keep the consistency up. So all these are doing is editing voltage levels that go into the rest of this thing. This one's doing freak, and this one's doing width. So we've got width for the control voltage in. We've got the frequency that it centers on, which is just biasing it towards negative, which is a little weird. And then we have our VCO mod control with a CV that can come in and influence this line. And then we have our main tuning knob, which can influence this line from all the way from 12 volts to the negative voltage. Never used Autodesk and starting to use it. This looks so much better than Spice by a mile. Spice is a totally different purpose for the program. This is a nice. I mean, I've gotten used to the Fusion thing. The program that I like, the one that I used to use at my old job, it didn't have multicolored circuit elements. That helps when you're doing what this program is meant to do. This program is meant to program your circuit layout. You don't necessarily need it to make a nice looking, easy to decipher schematic, but it does help to do that. You can do that in here. So slide input, we haven't done anything yet, and I have a feeling it's what's connected over here. But so far, we have been working on the elements of mixing voltages in order to influence the frequency that the oscillator sits at. It's going to use those transistors over there in order to influence a transistor, what is it, a supermatch transistor pair to wibble back and forth on itself. So, I mean, there might be a little bit of rearranging of the circuit in order to make it make a little bit more sense or look a little bit different, but for now, it seems to be doing its job right. Yeah, it's wiggling it, it's wiggling it around. So where is our non-connected going? Of course, I need to also mark down the stuff that I've done already. Oh, we've also gotten the CV in. I forgot to mark that. So let's do a little bit of marking. We got this element. We got all the way back over to here. And this weird circuitous path that goes up to here. And that's actually just goes to negative voltage, so I'm just going to stop there. So we know that that's negative V going in there. Is that negative V or ground? I guess it's negative V. So negative voltage goes into CV if nothing is plugged in. Oh no, so that's not negative V, never mind. Get rid of that marking, that'll be confusing. This is CV from an external connection. So we got that. What a walk around the park to get there. Okay, and then over here, we did our 100 kilo ohm, and we traced that back to, not the op amp, but to the tuning input from the front panel. Ta-da! Oops. Saving failed. What? Control S. Oh, do I not have permissions to save? Oh, God. I need to work on the permissions on the file server. We'll put this on the desktop. Replace that, yes. That's obnoxious. The file server doesn't let me save. This should have, like, full permission, but it just doesn't. I need to work on that. I need to look at the file server. It's still not totally worked out. Okay, that leaves the missing component, missing no. What is missing no going to? Oh, it goes to so much stuff. It goes to so much. Look at all this stuff that it goes to. Holy crap. Maybe we'll get back to missing no. Oh my God, it goes to everything. It looks like it's like a resonance from the output, like the very... Wait, that goes to a ground. Wait a minute, is this just power? Is this power? Oh, it is just power. Yeah, that's positive voltage. Okay, hold on. So we're not out of it yet. So that is power, which means that, where's my bottom layer? There it is. This one's power going to there. Oh, okay, so missing no just goes to positive power. Good, nice and easy. 12 volts. And that'll get rearranged. I'll have to rearrange that later. That into there. There we go. Okay, wow, that's good progress. Holy shit. So we got most of the inputs. The only thing we're missing now is slide input. Slide input seems to not interact with any of this stuff. It's possible that there's another connection here that I haven't thought of yet. Let me take a look at the schematic and see if we're actually done. This is just positive, so we can just mark that out like that. It seems like we've gotten most of this stuff. How can that be? I thought that slide would influence this line, but it doesn't look like it does. This is just influenced by a bunch of different little adjustments. So, in that vein, yeah, that definitely doesn't connect anywhere there. Oops, I just did that on the bottom layer, didn't I? Control Z. Control Z. Okay, redo that, and then go to done, layer. I gotta make sure to work on the proper layer, or else I'm gonna mess myself up. Make a note right there that it's plus. Okay, geez, there's so much more to go through, but it seems like we've exhausted that area. We've gotten all the way to this transistor right here. Right here. And so now we need to resolve what's going on over here with the remainder of the transistors. Cool, wow, why don't I buy viewers, you fucking idiot? Jeez. Little viewer bot assholes. And you know Twitch isn't policing that shit. So annoying. I've worked hard to get the viewers that I've got, all 12 of you watching me right now. It goes to everything. When you get into a situation where you have this circuit trace that branches into 500 different areas, it's like, whoa, hold on. Something's going on here. It's probably a power or ground. I am definitely human, says Groovy, in a strangely monotone voice. How many do we have on, Hello, human, says a first-time chatter. Where's, hold on a second. Where are, blah, 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 blah. My YouTube is over here. There we go. 3 viewers, all right. Hey, well met, YouTube. That brings us to 48 viewers. I know, who buys them? There are view farms where they have like walls of phones where people are doing stuff like that. I'm sure, you know, there are channels on Twitch that you'll find where they have 1,000 viewers and the comments are coming in as fast as my channel. And, you know, like I try to engage you guys. I'm not at a level yet where I need to manipulate you guys into actually like leaving a lot of comments. I would say a lot of weird shit, like, you know, make up a weird political opinion to get you guys all nettled. Or, you know, my opinions on building circuits and stuff are actually genuine, but if I had certain opinions about how to build things, which I kind of do already, but I could rile you guys into saying stuff and then my chat would be active. But I'm not at a level where I need to do anything like that. I'm not trying to serve you guys ads, you know? I talk a shitload. I should charge for my personal views. Listen, how do you think I got into streaming? You know, I talk shit all the damn time. That's why I'm good at this. That is a weird view. Why are we looking at... Okay. Talk shit, get hit. I keep chat super active. You've been talking a lot, and I appreciate it. Okay, so... this is becoming more and more spaghetti as we go on, but what we are unraveling is looking like this, which is pretty nice and organized. It's actually quite a neat little presentation of everything functioning here. I could pull this into something that's horizontal, and then it would take up a little less room on the schematic. I'm going to leave it as it is for now. It's just that I feel like this 12-volt element should be up top, and then the one that goes to ground should be at the bottom. This one should be at the bottom of the stack. This one should be at the top of the stack. And then somewhere in the middle of it, I can have this whole big thing coming off of it. Right now, though, I'm going to leave it the way it is. Unfortunately, that'll kind of plant it in space because these 2 switches are going to get stitches. Those have to connect somewhere. There's more circuit to go. I'm curious. I'm sure you can pull the schematic for the circuit you're working with, it being an older device. So the thing is, Acid Labs does not, and I don't look. I don't like going through patent applications, and I don't think they've applied for a patent on this thing. This is an M303. This is built by AcidLabs.de, a company that makes modular synthesizer modules. The M303 is a different design from the TB303. It is based on the TB303. The TB303 does not have to accommodate modular synthesizer voltages coming in and out of it. The M303 does. We need a specific schematic for the M303 so that I can go through the different elements of this design piece by piece to make sure that it works so I can fix it. The TB303 has an actual working document for it that they use in order to troubleshoot the TB303. So for instance, it'll point to a specific junction and say, you should see a voltage that looks like this. And we can do that we can look at this and we can actually see what we can find this signal somewhere. But I'm getting weird stuff too, and this isn't exactly how this is designed. There is a bit of a difference between the two different designs. For instance, like we have a switching element that goes to a capacitor in the middle. I wonder if we find this circuit, something similar to this circuit, from the slide. That might be the case. Those two switches might be slide influencing. Now, this document was made in order to service the TB303, so they put all of the external connections all the way over here on the right, and they pull all this stuff in all the way over here. It makes it difficult to read. It makes it hard to read. So the reason that I'm doing this is I want a document that will communicate to me, somebody who's looking at the design of this thing, how I should be operating with the rest of this. We don't have a specific schematic. I don't work for Acid Labs. Acid Labs, they probably have their own internal documentation. But in addition to having a good document with a good schematic, I can then make my own 303 based on Acid Labs design. Now, that would be super shitty of me to do and like sell it. That'd be super duper shitty of me to do. I'm not going to do that. Because I want an M303. I don't want Acid Labs M303, but if I make my own, I've done all of this work. It's just, it would be really scummy of me to just like steal their design. I'm not going to do that. The only reason that I'm doing this is so that we can go through piece by piece and create and fix this. And then maybe in the future, as a personal thing, maybe I could make myself a 303 based Acid Labs design 303. Because yeah, they would sue the shit out of me and like just leave me as like a half of a burnt receipt on the pavement in front of a lawyer's office. So we're not doing that. But we're learning a lot about how this thing works and the different elements of it. And I'm getting down to the nitty gritty of exactly what Acid Labs did in order to make their module, because I got to go through it. I got to go through its bones and make sure that it works properly. So I'm interested in this slide on off. What is this part here? 1403, we got some weird elements over here. This is a massively confusing. That's decay control. What? But I don't, no, that's too. I spent a week going through your design and I've redesigned your design to be slightly better. Do you guys want to sell it? Give me some money. And they can go, no, this is the dumbest thing I've ever heard. And then they'll squish me like an ant. No. I'm not going to do anything like that. But I could make a 303 like if I understand enough of the elements of this thing. I can maybe simplify it a little bit. I don't know. This is a very complicated design, though. There's a lot going into this design. So I don't think this doesn't translate into money in any way, shape, or form. The reason I'm doing this is to teach you guys what it takes. People have wanted to see the reverse engineering process. Here it is. This is it. It's work. It's a lot of work. Oh, Mudblood Dragon. Oh, sorry, Mudbound. Sorry, I was doing a Harry Potter slur. Mudbound Dragon. Been lurking for a while. This is really interesting stuff you're doing. Thank you. I appreciate that people appreciate how this, because this is a whole bunch of hieroglyphics. For those of you who are unfamiliar, every single one of these symbols represents part of a part or a part. And the connections of them tell us what's going on in the circuit. The layout of the different elements of this thing can help communicate that. So typically, I don't like having a voltage symbol that goes down and has a thing here, whereas this one points up. I think the up pointing ones are 12 volts, and so 5.3 volts is below that. This symbol right here is 5.3 volts. Having it go down like that is a little bit weird to me. But I guess it is below 12 volts, if that is, in fact, 12 volts. Where do we have 12 volts on this thing? Well, there's an arrow that's labeled 12 volts. There's a plus 6 volt. Jesus. There's so many different voltages here. 12 volt is the solid arrow. Open arrow is after a diode. What the hell? Weird. Set tuning, CV out, 2.75 volts is the A key. Oh, all right, I should have. Well, we'll have to get to tuning it later, but the Acid Labs synth might be a little bit different to Most of the 12s are for the ops. 12 volt transistor, 12 volt transistor. Wait, that's a FET. What's a FET doing in there? 12 volt adjustment, 5 volt to ground. That's limiting this. 5 volt to ground CV. Okay, well, anyway, this design is not the overly important one. What I want to see is what is influencing these switches, and it seems like slide is what's affecting them. Do we get any of those waveforms? Yes. We do actually have a square wave with a pompadour, as well as our sawtooth that has these gnarly little sawtooth, our tungsten insert sawtooths. But what we don't get is the thing after the filter, the penis ladder filter here. This is the penis ladder filter. And then it's a diode ladder filter. But anyway, we don't get this one from resonance. And so somewhere in there, something stopped functioning. I do get these two, although one of them is a little bit weird and rough. It's kind of at a wrong voltage level. So there might be a diode that's dead, but this is not precisely what we have in the other circuit. So that's why we're doing this. Yeah. This is messy. Yep, it's a very messy circuit. We get there, though. We get there, though. So let's take a look at the control for these two switches, because I have a feeling those go to slide in over here. So not necessarily pins 5 and 13. I didn't use the precise pins that I should have used. And maybe at some point I can swap the gates around to get them precise. I don't know. I don't think that's as important as long as I have this document. Although, to be fair, maybe I should be a stickler about which pins are going to which device. I don't know if I can grab the device only. GO was a command in the other piece of software that was so useful. Like, if you accidentally put the wrong element down, you could grab just this. And I guess I can hit replace, and then I can replace it with... That's replace the whole thing. Inductors can affect the current going through a charging circuit. Holy crap, it's just a coil of wire. Capacitors, ton of support. I don't know. Coils are important. Bears are crazy. They'll bite your head if you're wearing meat on it. So these come out below. I mean, I guess I could flip this thing vertically, but I should probably make sure that the appropriate elements are in the TLO74 and the TLO72. We got the right pinouts going into everything. And if I keep that up, then this can be much more referential as the appropriate document. Can I just grab this element and move it? I can swap the package, can I? Or swap package, breakout pins, replace, swap library, rotate, attribute set, spice model, new group. There was a way. I forget what it was. It's not... Oh, gate swap? Yeah, I can gate swap it. Okay, so let's go back to our CV and let's see what pin that goes in the TLO72. So go back to CV, which is here, and we're going into the TLO72, which is down and around and up, and then we go into... Oh no, that's where CV's coming from. CV comes from here, and it goes into a can in a factory downtown, and we're coming into pin 3. Okay, we got that one right. TL74. TL074. The one that we're going into is pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pin 10. Pin 10 is not this one. So what we do is we go gate swap with the one that has pin 10. Ta-da! That's gate C. Okay, so next we have our first switch. A switch goes into... Where is that? Our switch goes into... switch goes into pin 11. Is that right? That's the one with the beginning of the capacitors. So that goes to here. And that goes to capacitors. And then it goes out to the next one. So the first one is pin 11. I mean, of course, we got it wrong. So we gate swap. This one. Go. And then this one is going into... Where does it go in? It goes in pin 1. There. Okay, so our pins are now our pins. Oh, this one we got right. This one we made sure was the right one. Cool. All right, so now we're being a stickler for our A, B, C, and D gates. I said we didn't need to do that, but I guess we do. Okay, so pin 12 and 13 are the pins that we're going to look at. Oh, I got to stand for a minute. My butt hurts. Yeah, if we're going to use this as a working document, that's what I was thinking while I was working with this thing. I guess the dollar sign no longer indicates that it should go up in value or something. I don't know. Those dollar signs, there's a way to get rid of them. They're from the old version of the old way of doing fusion stuff. But okay, pins 12 and 13 are our switching pins for slide input. So let's take a look at pins 12 and 13. Now, the reason that we count the pins the way that we do is because these chips, the layout of chips, are actually a holdover from vacuum tubes. And vacuum tubes counted, I believe it was anti-clockwise, around a circle with a gap. And that gap was your pin 1 indicator. So you have a gap, and then you count anti-clockwise up in pin numbers, ignoring that this is also a gap. You have a symbol that represents the gap, which is the notch in the chip or the dot in the front of the chip. So we went from vacuum tubes to cans, from cans having the same numbering scheme of anti-clockwise with, in this case, not a notch, it had a pin. It had like a tab sticking out. We then went to square epoxy packaging that has a notch, and you count anti-clockwise up in numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 12, and 13 are the 2 control pins here. These 2 control pins are coming out on these 2 lines, these 2 blue lines, up and over to a bunch of Schmidt, pieces of Schmidt. Okay, so these go to a bunch of Schmidt triggers. Is that right? Is that Schmidt? Yeah, that's Schmidt. So let's go from the first one. Let's go from pin 12. Pin 12 goes to pin 12. Very inspired engineering. Very inspired. The pin 12s taste like pin 12s. So pin 12 into pin 12. Let's get our Schottky diode Schmidt trigger. Sorry. Let's get our Schmidt triggers down here. So I need to place just a buttload of things. I got to go into place components. And because I did this on my own, I guess I could have looked really smart by building the components in the CAD program. They've got all these new like little highlight features that help you lay things out and kind of makes them look right, which is pretty cool. What do you do? Where's my triggers? Mechanical? No, it's chips. It's on a chip. It's in chips. And this one would be not 4016? No. 3046? No. FT232? No. 4041? No. 13700? No. Where'd it go? Oh, was that it? No. I drew a symbol and everything for this. Did this get lost when I was, I had a crash. Fusion crashed on me because I had the the audacity to click something wrong, and it crashed, and I might have lost this part. Let's just look through. Oh, here it is, MC14106. There it is. So yeah, cool. All right, so I do actually have the part. The 1, 2, 3, 4, 5, 6, and then this thing needs power. So I'm going to right-click on it and do invoke, and then I get power plus minus, and I can place it in. Yeah, it's going to block stuff. Who cares? Okay, so pin 12 to pin 12. Pin 12 is an output. Wait a minute. Let's double check on that. Double check, and then I got to make sure that my pin out is correct. Yeah, pin 12 is an output, but it also connects to pin 11. Okay, so 12 and 11. We need 12, but then we also need pin 11. 12 und 11. Where were we going? Where we oh yeah, that's right. Pin 12 to pin 12. I don't know how to draw that. I don't know how I'm going to draw that. Let's just take it from... Well, maybe we should start on the other side of slide in. Probably go from the other side of slide in, since these are going to need a little bit of room. I didn't draw these very small. I probably should have drawn them a little bit smaller. Yes, I made these... Any reason you chose Fusion over something like KiCad? I have been using Eagle for the longest time. Before, when you were just a twinkle in your daddy's eye, I was using things like PCB 123 and Express PCB in order to make these things. I eventually went into using Eagle because that was like the de facto choice for any hobbyist building circuit stuff, and that's just what I was used to using. So when it came time to do Fusion 360, I can't really shrink it in the program. I could draw it smaller. I shouldn't need to draw it smaller. It's fine. It's fine in this size. Anyway, so yeah, when it came time to find an application to actually start making circuit boards in the modern age, I looked at, my old version of Fusion, which was the last one that you could buy straight up, and I had the Pro version. That was all well and good, but I started to use this program called Fusion 360. Well, I had used, actually, I think, Inventor before that. I pirated Inventor and used it a little bit to do solid design stuff, and then I kind of put it aside for a while, and then it came time, like I had a 3D printer and I have to design solid parts in order to do stuff. Well, I know how AutoCAD works. I learned it in college, so I might as well try this free program, Fusion 360. So I used Fusion 360 a little bit, and then I said, oh, look, they got Eagle. They absorbed Eagle into their thing. That's neat. I can make a PCB, I can render a PCB, and then I can build solids around it. And so that's why I use what I use. Just to the current feature. Check out later. What are we talking about? Oh, inductors. Yeah. Well, okay. So yeah. Anyway, these are larger than they probably should be, but they're the right part. So I'm just going to continue to use them as they are. Boy, that is a long value. So let's see. We should probably start from slide in, and we'll get back to these. So I'll put these up here for now. We'll just get in the way. Slide input. Let's just go from slide input, because I have a feeling that's what we're going to be working on. I have a strong feeling looking at the schematics. So instead of starting over here, let's jump on over to slide. So slide is just a CV coming in from over here. Slide comes across, under, and over, and around and down. And it appears to come in to some kind of fuckery. What is this? So slide input then goes to a 2202, so a 22K that goes to something K to ground that has a transistor on it. Huh? And then it goes through a diode. Through that diode, it goes to even more ridiculous shit. What the fuck is going on here? Okay, slide in is very interesting. Let's double check to see that that's our signal. That's all under the board. Under the board. Directly into slide in. Wow. Okay. Slide in sucks. Let's get this done. The more it sucks, the more we just want to get it finished. Wait, which one is that? That's F in. Wait, that's frequency. Hold on a minute. What is going on here? Something's up. Hold on. Slide in is on this pin. Nothing is happening over here. Except for this trace right there. Ah, yes, where it's not marked. Right, okay, so that was a little confusing. So it goes under there, and it doesn't interact with any of this stuff. Comes all the way over here, and then it does go into 2.2, 22K rather. Okay, so now I know. Now I know that we are actually right here. So we are 2.2K and a diode. The diode goes to that structure. What in the world is that going to look like? In the 2.2K, and this goes with the base going over to there. It goes to a bunch of stuff. That goes out into the world. There's a lot of stuff out there. It's a crazy, scary world. That one comes over there. What is this trace specifically? This is V+. So this is positive power. That's why it's going all over the place. So V+ through here, and then the 2.2. Okay, so we can start to put this together. I can start to get an idea of what that's going to look like. That's where I'm the expert, my friend. That's where I'm the expert. Do I have a part that's just a transistor? I don't know if I have an NPN transistor. Do I just have like an NPN? Is that a thing? Do I have one of those? Maybe it's in components. Those are LEDs. Cap, no cap. Zener diode. I have MOSFET. Oh, transistor, here we go. Ooh, that's a little bit cursed. Now, that's PNP, but I don't have a 3D model for it. Huh. We'll make a new part. I gotta make 2 new parts. So let us go ahead and click on the Edit Library button, and then we are in Components, Managed, and look at the largest. Wait, am I in the wrong one? It highlighted this one, but yet this is the higher version. Well, let's see. Look, there it is. There's a transistor. That might be a MOSFET. So let's edit this library. So right-click and hit Edit. And we'll make ourselves a PNP and an NPN. And I've got symbols for them already, so we're just going to wait for this to load in. Oh, I don't have a thing selected. Okay. MOSFET N, MOSFET P, PTC, resonator, blah, 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 blah. Transistor NPN and transistor PNP. Wait a sec. Do these have 3D models? They do. Oh, that's a really ugly. I don't like that one. I don't like that symbol. We're gonna bring in a better symbol for that. So let me do just get this out of here. That's nasty. That's nasty. Let's bring in our other transistor symbol. Oh, but I need to copy it from library to library, don't I? Whoa. Cancel. And then I guess I need to. How do I do this? Back over here. Go back to here. And then I need to go to chips managed. This one. Edit. You work with the circuit elements enough and you can kind of puzzle them together in your head and figure out what the schematic should look like from the layout. But it's juggling a lot of variables in your head. NPN. Can I duplicating it here will just make another one. I want to move it to my library. Maybe I can just cut and paste it. And I think in name and value, I need to put Q in name instead of... I don't know. See, I've been doing name and value like this, and then it's been putting $signs on it. Whereas in that other part, it just said Q. I don't know. Let's see if I can cut and paste it. So new footprint. And we'll call that NPN. Good. Because there's already PNP and NPN. I need to just make a new one. Oh, good. It does cut and paste. Perfect. So there's that. Did it not cut value? It didn't put value in there. That's weird. What layer is this on? That's on names. Weird. So I guess I just need to go to document and I need to put... Oh, I can't. I can place text there and then I can put it on values. And then this will be... I don't think... Wait, oh, it showed up. That layer just wasn't visible. All right, well, fuck it. That's done. Save. And I need to make another one. I call it PNP normal. Paste it again. Place it in. And this time, I'm taking the arrow and I'm putting it... Wait, hold on. What does a PNP look like? Why do I forget these things? Why must I always forget these things? Okay, yeah, so the emitter and collector are upside down, but then it's also the arrow goes inside. Listen, describing that to me is not going to help me at all. It's just not going to help. We reverse these, flip back, flip it, reverse it. Move this. Oh, it's connected. Son of the bitch. Son of the bitch. That ain't look right. I guess the angles are a little bit different in my symbol. Oh, that works. Almost. Yeah, that'll do. I don't know how I'm going to get this right again. Oh, there we go. It's a little weird. Oh, God. Okay, hold on. I can do this. No. No. Hold on. Let's reset the clock here. Okay. That thing was all over the place. Actually, wait. Can I... Oh, no, that doesn't help me do that. Never mind. I think it's editing the... Like, I'm losing the symmetry in it. That's a little weird. I mean, it's meant to be, like... It was fully reversed. Flip it there. It'd be like this. Oh, yeah, that actually... Whoa, no, no, no! Does that look okay? I guess so. I'd have to move it, like, way up in order to get it to... I can't do a slight move on this. Uh-oh. You have to center click to mirror it. And so I center clicked to mirror it, and then that put it on the right. axis, but I can't get it, like, I need it to be here where my cursor is. I can do it like that. That's close enough. No, listen, once you learn the tricks, it's not that fragile. Oh, that's the wrong layer. Ah! Yeah. Symbols layer. Oops. All right, there's our PNP. So we got our NP and our PNP. We have the package already. We have the three-dimensional package. We have the footprint that I like, and all that stuff is already all set. Oh, man. Okay, there we go. Belt buckles digging into my stomach. Save this. This is the PNP good. This way my whole drawing has all the same symbols on it. It's not something that somebody else drew. You don't necessarily have to go to this level with everything, but I'm just being a little bit of a stickler for those details. So now that I've got all this stuff in this library, I guess I can close this one because we already got what we needed from it. I can then build the packages that I need. Yeah, they're labeled emitter, so that says E. And this one down here is labeled C for collector, and then this one is labeled base. I built this thing yesterday. I built these parts yesterday, so I know their ins and outs. Okay, so that's all saved and well and good. Now I need to go back into the component manager and go to the assemblies, these things here, and I can go to transistor NPN, or I could make my own part. I don't know if I want to trust SOT23BEC. And then it's got that model associated with it. Oh, but there's no PNP as a symbol. And then there's just an SOT23. I'm going to make my own. I'm going to do, well, that was MOSFET P, MOSFET N. I could do trans NPN. No, you know what? I should edit these. All right, let's take a look at this one. So this one, we're blowing this away. I don't need this anymore. Transistor, this one is PNP. So I'm going to add an existing symbol, and this would be PNP normal and NPN good. So this one's PNP. Put that in there. Done. G1 and then value. Why is it all so messed up? That's annoying. Anyway, because this is a totally normal program, they decided that they would want to resize the window to be completely inoperable. That's all well and good. And then this SOT23 size, I'm going to delete. Yes, and make a new package variant with a local package. And then the package is limited to ones with 3 pins. And we should be able to find SOT23. We don't need 23 BEC. I don't think there's any advantage to using that. Although BEC does have a 3-dimensional package associated with it. But that's kind of a clunky symbol. That one has like a keep out area on it. If I do that, then I could associate the 3D model of the other one with it. So we'll get 3D. We will get 3D. So I'm going to do the one without the 3D model. It just has a placeholder. Click OK. Then I need to connect the pins. We can kind of peek in here and see which one's 1, 2, and 3. So the base on these transistors is this pin right here. So pin 1 is base. Connect. And then pin 2 is always the emitter. And then the collector's on the other side, pin 3. So there's our PNP transistor. And then I am going to go to here and delete the 3D model. Okay, whatever. So I can go here and do attach a copy of an existing 3D model, and I can go down here and I can find SOT23BEC. BEC2, no, I think it's just this one that I want. Yeah, select. Save that. Oh yeah, it's whenever I don't check. Let's check PNP versus NPN. let's do that again. Our egos are not that big. We can come down here to a very simplistic level, and we can eat our pride. We can slurp it up. So I don't need you right now. I need SOT23 PNP. Just make sure that we're doing the right pinout here. Dear God, I just want, no, too much stuff, please. BJT, bipolar, blah, 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 data sheet. Yeah, so the emitter's on that pin, and let's just look up at NPN. SOT23. Find a PDF. I mean, there's plenty of PDFs on Twitch. All you have to do is look at some of the top streamers. I mean, for the electronics parts, we can look at some of the top results from our search. That's a Darlington. I don't need Darlington. Get out of here. Get out of here, Darlington. What is it, Darlington? I said NPN. Darlington. Everything's Darlington. It's probably, I can probably, yeah, Darlington transistors. These are like searches that just get, oh my God, what the hell is that thing? Let's see, Diodes Incorporated, Darlington, damn it. This has a bunch of search terms that I don't need. I'm just going in through Google, so. I just want confirmation of the pinout of an NPN. This is the furthest thing from what I need. I could search Mauser for it. Why is this NPN SOT23? All I care about is what... Okay, they do this three-dimensional drawing thing that's never not confusing. So base and emitter. So the emitter is always on that pin. Okay, I thought they might switch it up just because of the difference in use for the two. So this is all correct, except that the 3D model is not propagating to this. Why is it taking me over to the 3D models? What's going on here? I thought I saved the 3D model in association with the pins. I've had this happen before where it like doesn't quite do things. What is going on here? Package isn't found on the current team hub. Cancel. I thought we attached it already. I thought it said it attached. Do I need to do a new footprint? Do I need to copy that? The attached copy of an existing 3D model. And then I can find the SOT23. Yeah, there's different ways to edit this, and I never know exactly the right one. So if I attach the one that's 3D, the SOT23, it's there, bottom. What are you talking about? This is the placeholder. Oh, here it is. No, this is the different, that's the different one. I didn't work on that one. This is the one that I'm looking at, SOT23, and then I'm adding attach copy of an existing, and I go down here to SOT23. SOT23 right there, 3D model, select that. That just kicks me over to here. God, why is scroll so broken? The scroll wheel's very broken. And then SOT23, oh, I got a couple copies here because I'm irresponsible. You can edit that and put it on its footprint, but it should have the footprint of the other one. And this is already centered, which is, I'm worried about that. New, no, that's not right. Variant and all that stuff is in there. That SOT23 should be in there. But it seems like it's not basing it off of the footprint. If I save this... Now, see, it's just not... It's not doing its job. I think maybe I just need a new package on this thing. So, I've seen tutorials on how to do this, and there's a couple different ways, but it's like, don't use a placeholder. Delete. No, it like wants to delete it from everything. I want the association. Let's just do local package. We'll do a new one, and I'll do... See, the problem is I want the footprint. I want to mix the footprint with the different part. Oh, see, look at that. That one is... Okay. So you need to add it as a package variant, and this will just be SO. Yeah, see, this one I can now delete. And now I just need to map the pins. So base is on pin, and I can squint in here, pin 1, okay. Base is on pin 1, collector's on pin 3, and emitter's there. Okay, cool. So there's our part. Cool, we made that one. So now I can save it. And what I want to do is upload it to the cloud. So I need to go into Manage, and I need to hit the Upload to Library I/O. Create a new version. That just makes sure that my two computers have the synced libraries in them. Oh man, you have to, so when you create a new package off of the footprint, you have to then reassociate that stuff. So you need to add a new local package, and then you can get rid of the placeholder. Because the placeholders are just these boxes that go over where the chips are. I want to be able to see the full 3D part. It looks really cool when you render out your whole circuit board, and it's got all the parts on it. It's really cool. What is taking so long here? Please don't crash. User saved. Cool. Okay. Transistor, NPN, doesn't got nothing going for it. So I'm going to go to device, and I'm going to use... These buttons will get you everywhere. Unfortunately, I guess they decided against having like pull-down menus. You might be able to like right-click stuff to get certain functions, but it seems like they want you to push the big dumb button in order to get stuff done. So you push the big dumb button, and I use NPN good. I'm going to put that right in here. Bada bingus. So there's our NPN. Our arrow's going out to the output. We already have this stuff associated. I probably could have used this from if this already existed. Although, was this the pin? Yeah, this is the one that I wanted. Weird. I already had it. All right, whatever, connect. And so base goes to base. Well, I probably made a big mess of those 3D models. So I probably have a bunch of 3D models that I don't need. There's no numerical value. What do you mean? G1 value, is that different from this one? Well, the numbers I'm about to associate, so base goes to pin... Oh, yeah, you're right, these VCE instead of 1, 2, 3. Maybe we don't want that. Maybe we don't want that. So I'll need to add a local package to this thing. So new... local package, and we go all the way down here, and we choose the same one as before. There's a big mess with my 3D models, and it could really be unified. It's such a mess. I wish there were better tools in order to unify this stuff, though, because these tools are clunky. Like, which one do I use? I think it's this one that I want. And then this one I'll delete. And so now our package is consistent with the other one. I'm going to rename it to SO. And then connect the pins. And this time we have 1, 2, 3. So base is 1, emitter is 2, and collector is 3. There we go. That's a big job. That's why I'm saying I need to take like a month off to do that. Yeah, I literally already said all that. It is a big job, and getting through this clunkiness is awful. But what I need to do is, if you'll notice, this is called Jesse 2018. Well, no, you're saying exactly what I said an hour ago. That's the fun part of it. No, but like, this is called Jesse 2018, and the date is supposed to be hilariously off. I should make like a Jesse 2020 where I move everything in and I keep it nice and neat. Yeah, okay. Well, you weren't here an hour ago, but I did say exactly what you're saying. Save. So I agree completely. I agree completely. All right, let's get this thing up on the cloud, and then we don't have to do this anymore. This is what I did yesterday. I did all this stuff yesterday to try to avoid doing it on stream, but you can just see the process behind some of this stuff, making the various components. Oh, dear God, it's closing time. We'll go over just a little bit. I at least want to just get an idea of what this part of the circuit is doing. And then I'm going to continue doing this on my own. I don't know if we'll be doing this tomorrow. I don't think it's a good subject for a Friday stream. I think we should probably do something else, and I'll try to figure out what that something else is. But if I'm feeling completely uninspired, we'll do this again. We'll keep working. They're good, chill streams. I do not do everyday streaming now. It's Tuesday, Thursday, Friday. I need time to like order parts and stuff for projects. Right now, a lot of our stuff is involving music stuff and reverse engineering, so I've been leaning into that. So I don't need a 3D model on these in order to create this schematic and use it for Dave's synthesizer, but I need the 3D model so that I have consistency throughout all of my parts. I want to make sure that the stuff that I'm putting down is the best that I can muster. So, all right, we're done editing the library. Now we can finally put that transistor in here. So this one is which transistor? This one is an NPN. I marked the PNPs with the P. This one is an NPN. So we can go back to our components. I probably should put PNP to lead, but then NPN and PNP. Yeah, maybe I should like shorten this to trans. So NPN goes in. Oh my God, that value is just way too long. That is way too much text. There. Oh no. I've been waiting for stuff like this on Twitch forever. Kind of mad I only followed you now. Most stuff on Twitch is 3D printing or people writing terrible code. There's a whole mess of us. If you hang around long enough, you will discover people like Flatulent Gonad, Uwo's Lab. Oh man, there's so many. There's a lot of people doing this kind of content. I see them a lot. I've been doing this for a long time. And so I see people come in and out who do this. There's VTubers who do electrical engineering stuff. You can't write good code if you've never written terrible code. This is true. My dog is going crazy at the door right now. I think her friends are out. Okay, so what does this circuit look like? I had it in my head a minute ago. Oh, I have to say terabat in order to properly communicate everything. So right now, we have an NPN that is leading to what I wait a minute. What are you? Is that really positive voltage? It appears as though it might be. I didn't mark that on the proper layer, did I? Yeah, that ends there. How in the world? Wait a minute. Oh, I see. So that goes under. Is nothing connected to that pin? That's weird. Oh, no, that's a transistor pin, right. Right. From there, oh, I see, and then that connects at the top. Does that actually go where I think it does? Hold on. Oh, it goes behind the chip, and then it connects to that pin. Why would you do that? Why did you do that? Wait, what? Huh? Oh, this is the positive. Oh, I see. That's why you would do that, because you're routing it throughout the entire board. So that's positive power. And it goes to not that pin. Oh, I see. Okay. All right. All right. All right. All right. All right. We're okay. We're okay. Okay. Yeah, that goes down to ground. I see. I see. I see. I see. Oh, but we're not even working there. We're over here. Down to ground. Up to positive. Question mark. Surely it does not go there. That is a voltage source. Wait, that's positive power. Positive power. That's plus V, so that's 12 volts. 12 volts wouldn't go to the base. Hold on a minute. No, that's plus comparator. Okay, we'll get there. We're getting there. What's up, Madam? Game dev coding, and there's no way you can game dev for a job that's code is whack. There's a lot of people on Twitch. People do all kinds of stuff. It's very fun. It's fun. Fun. Oh my god. So we're getting into some of the circuit elements on this thing, and I've got various layers that I can use to reference what attaches where. We're trying to get into the slide control, which is a little bit weird, but the slide control, I know from my notes, slide in, a control voltage for slide in, goes to this pin right here, and that pin right there connects to this trace right here. That trace right here comes up and around, and I'm using blue for the bottom layer, red for the top layer. This looks like a total mess, but it's my mess. I know where things are. So this comes around here from the bottom layer of the PCB. You can see where I've highlighted the trace, and comes up, and it hits this little cluster right here, this little doodad right here. Now this has some kind of a diode on the anode of the diode into some more transistor stuff. So there's a lot of shenanigans that are going on around here. A lot of shenanigans. But we're going to get to the bottom of this through sheer brute force. So slide control's coming in over here. So the first thing we're hitting is a 2022, which is 2202, which is 220 with two zeros at the end. So that last number is the number of zeros, number of decades. You can math all around it all you want. I just draw zeros. So 22000, 22K. So let's put that in. Let's put that in before we confuse ourselves and hurt ourselves in our own confusion. So 22K going into what part of Q1? Well, let's start with just this line comes over here, and then we have a resistor. A resistor. A resistor. Why aren't these in alphabetical order? Oh, these are components. Resistor should be, why is resistor all the way down here? Okay, whatever. Resonator, capacitor, varistor, resist. Why are these in a weird order? Okay, 0805, I keep choosing 0805, and it keeps not choosing 0805. 0603, maybe I would build with if I go with a smaller design. Like if I really want to pack this thing in. Just use free energy. I saw a dude do it on YouTube. It's true. Man just made a Pokemon reference casually and then proceeded like it never happened. Dry pan humor is what you get here. Where does this one go? Hold on. So it's coming in and it goes across that, and then there's a diode. So I guess I'm gonna put, I don't really know how to structure this at the moment. So we'll just do this. I'll just go straight out into this R16, and then we'll give that a value so we can track it. We don't have Q's and R's. We have values on all of our things. So the value for this one was 220 or 22 2200 22K. No, that's too many twos. Carry the one, 22K, and then it goes into that stuff. And then over here, it goes into more weird things. It goes, I'm going to do the diode downwards, I think. So it'll sit below this. Let's just put the diode in for now. We'll do that. And then I'm going to do diode. Do I have a good small signal diode? That's a Zener. I'm pretty sure I've got one. If anything, I've got that Schottky diode. I know that's not what we have. It's like a small signal diode in there. 1N4148. That's a small signal diode. Do we have any 3D models? We're not putting that in. Diode. Here we go. I got a couple different packages of diodes here, and I don't know which one we necessarily have. I'm going to go ahead and assume that the 0805 pad size is going to be what we use here. So put that in, and then I've got just like generic diode. Yeah, put in a Zener and name it Replace Me. No, I'm just going to put in a generic diode, and you know, that'll be a parts ordering issue. That'll be on future bother to order the correct part. Does that go into the base? I'm not sure if it does. Let me double check that. It does go into the base, and then we've got a 1002 going to the emitter, which is ground. 1002, so 10K, which is pretty common. So I'm not going to draw that around. I'll just put 2 grounds in there. So let's copy that floppy like that, and then copy. I don't remember making the Pokemon reference. Frying pan is a drying pan. All right, like that. And we'll copy the resistor. Drop it in right there. We'll probably need a little bit more room for this part of the circuit. And drop that thing like that. And then the value of this one is 10K. And let's stack that shit up right here. What's going on? Escape, escape, escape. You gotta hit escape a lot in this program. That, we'll use alt spacing, go there, and 10K below it. Looking good. Oh, it's off by 1. There we go. And then wire it up. Too close, too far. Ah! Okay. You. Nope. You. Nope. You. There we go. There, there, and there. Shorten that up. And then we have also over here is another ground. That. Let's pack that in. That pretty much goes directly to ground. All right. So on the collector, what are happen? The collector. Oh, it's doing all kinds of stuff. It has a 2202 to positive voltage. I believe that's what this little cluster is here. Yeah, that's plus V. Plus V. Double check. Yep, plus V. Okay, so 2.2 to positive. Like that. And then let's get a 12 volt. Where was the 12 volt? There it is. Drop that sucker right here. Yeah, it gets around. It gets around. If anything, this is a voltage divider between 22 and 10, but somehow that's biasing. So should that be vertical? I'll just put it back for now. Oops, it's upside down. Huh? How did the value get above the... Weird. Weird. Should be the other way around. Why did you get... Did I, like, mirror it? There. That's a little weird still. All right, what's going on here? What is that going to look like? I think that's going to look more like a voltage divider than anything else. So I believe that this should go down a little bit further, and then we should take this. Well, I don't know where this is outputting. There's more to this. But I'm going to do it like this. Oh my god, all the traces are all messed up now. Let's just free you from your bounds. Your bonds. Like that. Of course, that makes this whole part of the circuit that much more space unfriendly. Yeah, between 16 and 17. So we're dividing our CV input, and then we're putting it into a transistor that is then biasing this pin to ground here. And we got to figure out where else that's going. And it's going through a 22K, so that's your current limiting resistor for a voltage level signal. We got a lot of stuff with 22Ks. I guess I could line those up and sort of put them together, but this needs to be a little bit closer. Just like that. We want to be space conscious. Okay, D2. What is that part of the circuit doing? Although the 22K, I mean, both of these things will go into various... Okay, so... that collector through the 22. That's positive voltage through the 22. There's the collector. And that collector signal on the other side of the resistor goes somewhere. Where is that? Where is that? Let's get rid of the bottom and top. Let's get rid of the IC marking. This is the line that we're looking for. It seems like I don't pick up on it anywhere. That's not good. Why is there a big gap right here? I must have messed up and... Let's see what the bottom of the board looks like. Aha. Huh. That sure is confusing. So it's definitely not traveling to the upper part of the board. It either goes to, well, if it went to this pin, it would go to ground. Went to this pin, it would go to ground. So it probably goes to this pin by process of elimination. It just goes in right straight over to there like that. That pin is what connection? Oh, it gets around. Oh, it gets around. That one goes to the op amp. It goes to a capacitor to ground, and it goes to... That's the power pin for this thing. Wait, that's a power pin. That should be plus voltage to the... So if that one goes to plus, that doesn't make any sense. That shouldn't be. It doesn't make sense for that to go to plus. It doesn't make sense for that to go to this pin over here because that's a ground. If it does go here, oh, maybe it does go right there. So we can ohm it out because I still we're not just working from images, but luckily enough, we're not just working from images. So what we can do is we can probe it in with the multimeter and figure out where it's going. You know, sometimes with my old reverse engineering job, you guys are tapping into like 10 years of experience of reverse engineering stuff. And what's happening right now is I'm starting to work purely from images, which isn't the way we have to be. We have the physical circuit sitting right here. So the area that we were in is right here. And we were looking at this pin right here and trying to find out where it goes. So we go to ohms, not beep. Do not use the beep. The beep is useless. You should learn to hate the beep. And I'm going to look at this pin here and find out that it's got 21 kilo ohms on it. So what 21 kilo ohms is this right here. This pin is connected here, 0.5 ohms. So I go from here to this pin, which is the other possible location, 1.7, 1.0, 0.9. There we go. No beeps. What are we reversing? This is the acidlabs.de's M303. My buddy Dave plugged it in wrong, and he broke it in one way. And then during testing, I plugged it in even wronger, because I am that much bigger brained than he is. I have a galaxy brain that's able to break things in totally unique ways. And so we've been kind of making up for that by trying to fix the damn thing. And it's not been going good. I have spent months working on this thing. Yeah, I plugged in the PCB upside down. So I've spent months on this thing, and I have not had all that much progress with it. We've been kind of going in circles. Everything works, but everything's broken. So what I'm doing is I am, yeah, Gateway Galaxy Brain more like. So I have been going through this piecemeal, cell by cell, and reverse engineering all of the parts of it. Now, we've taken images of this, and I've traced the images on this program. This is our working notes sheet. So as I go through, I can mark stuff off that I know, and just, you know, have like a working document. I also have notes in my notebook, but it's better that we go through it this way, because I can mark off all the stuff that I've actually done. And so I know the areas that I need to work on the circuitry. We're going through it. This is an M303. There's no documentation on it, but it's based on the TB303, which we have extensive documentation on. And the TB303 was the OG. It's what Acid Labs made to replicate in this other circuit. There are differences. There are many differences, but there's also a lot that's fundamentally exactly the same. So I'm going through right now, and we found these two switches, and switches get stitches. So we looked at what's feeding the switches. And so I'm looking at and sort of piecing together what's feeding that. And it comes from slide on off. So we've been able to piece together some of the slide circuit. I don't know what that diode is doing, though. This is where things are getting a little bit weird. But Fusion 360 allows us to have a nice, clean, and consistent layout for everything. So this is going into pin 13. And that's where it associates with these two switches up here. So pin 13 of these, we can bring that down. Come on down there. So pin 13, and then pin 12 connects to pin 12. We can clean that up later. What I'll do is I'll just connect it for now. Pin 12 to pin 12. Actually, want to move that over a little bit because we're not going to have room. And then that goes to pin 11 as well. It's starting to look a little bit familiar, though. Starting to look a little familiar. So the output of that one goes where? So we got 12 to 11. There's no other connections there. Just a little bit of sloppiness. Oh, there is. Wait, hang on. It goes somewhere else. So this junction comes out here, and it goes to the control input for the one on pin 6. So that also comes down here. Now I don't do four-way junctions. The reason behind that is that if you put a junction in there and it looks like a four-way and there's no dot, then you don't know. It's like, what does this mean? Is that a mistake? Did they forget to put a dot in there? Or is that a four-way junction? So my rule is that I don't do four-way junctions. There will never be a four-way. I only do three-way. It also prevents you from drawing swastikas all over your fucking design. So anyway, I never do a four-way junction. That way, if you see a cross like that, you know it's not connected. You just know. It's no way. It is pin 6. I remember this one. So what's happening here? There's a lot of business going on in this area. Pin 6. Oh yeah, maybe that is the wrong pin. Hold on one sec. Whoa. Okay, let's go back over to where we were. We were looking at this one here, and that drops to the other side of the board, and it comes over here, and it goes down to this one, and then I've got a bunch of mess. What is all this mess? I've got a ground pin here. That would be the... Is this thing getting powered off of 6 volts? What's going on? There's like a slash in here. What's that about? What was I doing? We pulled all these chips, by the way. We pulled all the chips, and I looked at the traces underneath. I think I'm tracing over that. Oh, that's an artifact from the outline of the chip. I see. So that connects there, and it goes to a dot right there. And so that's just going there. Okay. So that does not go to, but it still does go to pin 6 and 5. Weird. Weird. I says to him, I says. Okay, so we'll go here with this. It's controlling a couple switches. It is, it is. Good luck with the stream. Ah, thank you, my Aegis. All this. Oh, that's not moving with it. Yeah, I'm just going to bust this out the other way here. That. There we go. Nice and easy. Now, pin 13, I'm going to have to somehow get out of here, so I might need to spread this out or pack it in. I don't know. Try to, like, make room. I don't want it to be all lopsided. I'll have to figure that one out. I mean, I guess I could go up and over, but then I have to cross all kinds of weird stuff. Because I think pin 10 goes to that pin. So let's just check on pin 10 where that's headed. Oops. Pin 10. The control. Not pin 10. Wait a minute. Pin 13. Oh, good. It made the squished it. I squished it. Pin 13 over here, other side of the board, goes to that, which goes over to pin 10. The 10 to 13 is indeed a thing. And it would be very nice if I could get a line down from here. I can kind of move that over, I guess. It makes it uglier. We can do that. That'll accommodate. It looks like crap, but it can accommodate. Pin 13 should be to pin 13. Well, but, oh, I see. Yeah, if you swap these two, then it would be 12 to 13 and 12 to 13. You're right. You're absolutely right. The beautiful symmetry of this design was completely ignored. Another way that I could do this, if I could maybe give this part a little bit of space, and I can come in from above with those two lines to go into the two switches. Although that would break my CV line here, because I like this CV line going across. But if I could move this over to the left a little bit more, I could maybe have these go up and over and down. And that would make it a little bit cleaner than having these two drop downs like this. Because this is, I like the symmetry here, but I guess we can't, you know, beggars and choosers and all that. We'll be all right. I can make a little bit of, no, I can't really make room. I don't need to. I should definitely move 12 volts up here, though. That's all right. Okay, we're moving on. We're moving steadily through. Actually, here's what we can do here. Move this in a little bit. Bring that in. Tighten it up. There we go. Hey, so far so good. Look what we've been able to do. It looks like it's 6 o'clock for me here on the East Coast. Although I am gaining viewers because as time goes on, we get more of them people coming home from work and stuff like that. You know, as the West Coast and others come online. This is weird. They're using some kind of an analog switch in order to do some kind of like a slide triggering. When you turn on the slide, I guess those capacitors are then discharging that line to ground or something. So I guess you get just kind of like a little bit of a more easygoing, or no, it's feedback. Well, this is strange, right? But as we proceed, we will get to know the circuit more and more. Tomorrow is Friday. Should we be doing this on Friday? I don't know. Do I want to be doing this on Friday? I'm getting into it. This stuff has got me. I'm starting to like super focus on this stuff. So I'm not sure whether or not we will do this tomorrow. I know you're enjoying it. You're like the only one. I appreciate the fanfare and you know, you guys sticking around for this kind of stuff. We're moving through this design, and as we move through this design, more and more the parts of it are going to make sense, and we'll be able to sort of figure out how this thing is functioning and why it functions and who it's functioning for. And then I will be able to take the different areas of the circuit and isolate them and test them and make sure that they're doing what they need to do. For instance, with this, I could maybe not pull the... I mean, I might pull the IC and take a look at the voltage at pin 13 and see whether or not that is appropriately going up and down as I give it a slide input. You know, things like that. I can take the CV path and now I can take a look at it, remove this transistor and take a look at it, you know, all the way out here and make sure that things are going into this that'll allow it to function properly. Electrical engineer, but better because we can program. I'm on the other end of that. EEs have to be able to program. That's just part of the whole thing. I guess the ECEs did learn a little bit of circuit stuff, but they had a very cursory education on it. Are these going to complex structures? It looks like they are. The later ones? That is switching a thing. Switching a thing. Yeah, it does go to stuff. All right, well, anyway, we're gonna get back into it tomorrow, probably. If not, I'll have something that's a little bit less cerebral to work on, and maybe we'll have a little bit of fun with that. I don't know exactly what I have lined up at the moment, but all right. What's that from YouTube land? Like what you're doing? We seem to have a small break to chase rabbit down a hole. The idea is to learn the thing we're making progress. Yeah. Unfortunately, this circuit has beaten me in many ways, including mentally, to the point where I need to do something else with it. And the only way that I'm going to move forward is by getting exactly what the circuit is down on paper. So we get to see what Acid Labs did in order to make it 303, and then we get to sort of understand how this thing is functioning by virtue of looking through all of the circuit elements and what they're doing. We see things like where they're mixing all the different control voltages in order to create your typical transistor versus transistor supermatched pair oscillator. It's something that the m303, I guess, does internally. It's something that you see in a lot of these designs. A lot of these VCO designs are like this. Okay, so yeah, I went to Drexel University, so a million years ago, back when 3D printers barely worked. I will be back tomorrow. You guys will see me tomorrow. We'll see what we're working on then. We might just do this again. I know that I am hemorrhaging users. I know people who watch the stream, losing them. That's okay. But that just means that I need to pivot and do something a little bit more exciting. So I might do that, or we work on this again and I just deal with the realities of my sliding user base. I'm sliding away. But I will be back tomorrow. In the meantime, people have mentioned today, like Uo's Lab, Flatulent Gonad. There's a bunch of us out here doing some cool stuff like this on Twitch. Just let the brain relax. I'm not going to sit here brain dead. I listen, I always have a project that's driving us forward. So we'll figure out. I mean, probing around for signals on the PCB was like really fun to do. But I don't know. I need to like pull something apart and look at how it works or whatever. I don't know. We'll see. Here's the end card. I don't think any of this stuff has been updated. Let's just see if it says tomorrow. Yeah, the next stream will start in approximately 21 days. I got to update that command. OctoJ's been busy with life, and that's great for him. He can do whatever he wants. So I'll be back tomorrow. No, I don't want to hear your crazy sketches. I'm done streaming. Goodbye. I'll be back tomorrow. You guys will see me tomorrow. In the meantime, go touch grass. Do it. Just do it. Just go touch the grass. It's there for you to touch, and you'll feel better about yourself.